See if that does it. Yes, it does. Okay, perfect. I guess I can make it public right now.
Yeah.
Hello,
everyone. I think we are currently live, and I will call it global, actually.
Yeah. One second. Let me share this.
Great. I think you can check the things while Colin is checking his own system. Yeah, no.
Yes.
Okay. So everything sounds good. So let's start today live. I think this was some good opportunity. We thought that we were close essentially to this ICPC World Finals, which was supposedly in 2 weeks. It is not the case anymore. I mean, unfortunately, due to this war situation in the area. And I mean, essentially, I want to just say, I mean, it started with some terrorist activity, and then it is, unfortunately, there are lots of lives that lost, and condolences to the people who lost some family member during these things. But anyhow, as an end result, this is also that we don't have the contest now. Now we were ready to go to Sharm el-Sheikh in Egypt. But now I think we will start talking. I think this was a good opportunity to talk about competitive programming. We both have done that, and different stages, different eras, I will say. We can talk about our experiences. And I have also some plan. I think, especially, I appreciate Colin because of the website, the YouTube channel that he has talking about thinking and coding. I think that's a good opportunity also to talk about this, because I want to go a little bit beyond, like talking more also after these competition programs. What do we want to do that? But we will talk first, before, during, and after. And please feel free to join us. I think Colin's YouTube or my YouTube channel, or as well as my LinkedIn. Also, you can put the comments or questions, and we will be happy to answer them.
Yeah, it will be. Also, I'm not sure if people know about this. Like, I don't know if everyone got that email, but they did like straight up postpone World Finals because of like the situation nearby. So like, I'm not sure if everyone knows that, but yeah, basically the competition is not happening for a while. It's kind of a large deal.
And worse than that is this is second time, unfortunately, at Egypt. I was also about to go there essentially, I don't know, something like around 10 years ago, and that the same thing again happened there essentially. But anyhow, that's the life essentially, something beyond all. But let's introduce ourselves a little bit for the people who know us. Then this is a more discussion that we are doing with Colin. I will ask him questions, he will ask me questions, and of course, you are welcome to ask questions if you are at YouTube and if you have anything. So I'm Mohammad Hajiaghayi. I'm a professor at the University of Maryland, College Park. I actually got my silver medal in IOI Informatics Olympiad, an International Olympiad in Informatics in 1997. I got my PhD from MIT, and then I've been also with lots of industries. I was a postdoc at CMU, and then lots of, and my master from Waterloo. That is a interesting thing about these three universities. But also, I mean, I have been with lots of companies as well, like Google, Microsoft, Amazon, Overstock, IBM, AT&T. And this is like, spend a lot of time also on this one. So I think we will maybe briefly talk about this one, but more about competitive programming. And I mean, I have several awards on, like, of course, after this one, like Guggenheim Fellow and several other fellows of ACM and other things. That we will talk also about after the competition part, essentially, about this thing. Good. So I think, Colin, you want to talk about yourself as well?
Yeah, sure. So I never did make it to IOI. I got held up at the USICO, with like the US selection. I got seventh in that, but that is not top four. And then I moved on to ICPC, which we did pretty well in. We got third in the North America Championship. And beyond that, like competitive programming wise, I do a bunch of other things like codeforces. Some of the sites I've gotten pretty high rated in those. And yeah, I'm also specifically an undergrad CS student at UMD. And of course, I have a YouTube channel, which people know me for. Yeah, I suppose that's it.
Great. So I think that is the thing. This is actually interesting. I had actually a quarter from China who got gold in IOI.
Mm-hmm.
And I was always talking that I appreciate more you for being a team in China comparing to the IOI. Getting the gold medal in IOI might be easier.
China
might
is
be easier
so
to getting the top for people essentially in China. The same also in like US. It is like I think I got it. I went from Iran team. It is like I think the US population is 4 times in Iran. So in that sense, essentially, it's hard 4 times. I mean, again, these are the things that maybe there are also some of these contests are more popular in some other countries. But definitely in China, it's very popular and the population is huge as well. So
yeah,
it is,
yes. Yeah.
So that's about these things. Good. So I think given this intro, so I think, and as I mentioned, this ICPC was a good motivation for us. And I think that is interesting that I mean also, think that I mean I'm the coach of the University of Maryland ICPC team. I was actually I was also participant in ICPC. I think that was around 1999, and our team essentially was very ahead of the first team. But there was one problem. We will talk about this one. One problem that at the end we couldn't make it. We were so good in terms of timing that if 4 hours after the contest, if we solved that one, we were the first. But unfortunately, another team became, so we became second. And again, second team potentially could go over the world final, except that the first team also was from the same university, Sharif University. So we couldn't go to the world final. But after that, I'm actually the coach of University of Maryland team since 2010. And of course, it's great to have Colin this year in our team, along with 2 other people. I think give the credit to them, Kayvan Rezai and Mohammad Hajiaghayi, they were our team. And it was a great team. These are like one of the best things. And yeah, this year we got the 3rd rank in North America in the national North American competition. That, and as I mentioned, Waterloo became the first that I got my master there. CMU became second that I got my postdoc there. And then UMD I'm working, and then I think MIT it was not. I hope that it became actually 4, but actually MIT became 6. I think.
No, they got like 9. They had terrible penalty. Yeah.
But anyhow, that's a generally good team because they are borrowing the best people essentially along the whole world essentially, especially for graduate and even undergrad. But anyhow, so these are some joke about it. But good. So let's start about this one. Let me tell you a little bit how did I start programming. I think it's quite different from your experience.
Probably, yeah.
So yeah, so I was born 1979. Become like an old man. It's not that old, but I think. When did you?
It was myself like late 2018, like pretty much December.
But which year?
2018. Like.
Oh. No. What is your the year that you were born?
Oh, born? 2003. Sorry.
2003, right?
Mm-hmm.
Yeah. So the Gen Z, I think, that you are mentioning. But anyhow, so I think that's interesting actually. But this is interesting. So sometimes this IOI and ICPC is something that essentially the ICPC interestingly actually was before IOI. The people may not know that. But maybe it's not that global at some point. But actually, it was anyhow very well-known things. And maybe for the people who may not know the exact difference, we should mention that the IOI essentially is for high school, essentially probably the most well-known program for high schoolers that you can get a distinction there. And ICPC is the most well-known competition for undergrads and maybe first or sometimes second year grad students essentially. So that's the thing that relates them. And I think I went to maybe it is around the 9th competition in IOI that I went there. So it was early on.
Oh, wow. Yeah.
Yeah. So it is like, the time passes by. So the time that I started essentially for me, like I was in some city, Iran, in near to, Tehran is the capital, but I was in Qazvin. And there, I think from that city, there was, the math competition was before, by the way, there's the IMO, which is the Math International Mathematics Olympiad. Yeah. That also was, essentially was there for a while. Mm-hmm. And for me, that was interesting because when I started, there was no person from my city that went to essentially, even the camp essentially. In Iran also is very competitive because it is one of the things that the people consider if they can get a medal, etc., they can apply abroad and go to the top universities like in US, Canada, or other places. So it is quite, but I think in my city, it was like 10 years before me, only one person actually went and he could get the bronze medal in IM, but no other person. So I started essentially writing programs. At that time, it was this kind of floppy disk essentially. It was like quite hard for them. And by now, essentially, by this standard is quite different there. And I started actually with C and then C++. But it was interesting. Like even I had a computer that had only 40 megabytes of drive essentially.
Wow.
So, and you cannot believe essentially 40 megabytes. And then I wanted to essentially install Borland C on it. And the Borland C was around something like 50 megabytes.
Right.
Okay. So before I had like the thing is like the first one I had 60 megabytes, but it had 1 megabyte RAM. Mm-hmm. Then this 1 megabyte was not enough to compile a program in C++, in Borland C especially. I'm not so sure that nowadays the people know even what Borland C, but that was the main essentially compiler. There was Turbo C, which was smaller, but Borland C was the complete C++ if you want to use it. And then I needed to change actually my computer. I bought it and then my mom bought it. We need to change it such that, and then there was a limited budget. So we need to change it to 2 megabytes of RAM and 40 megabytes of like essentially memory, like a hard disk. And then the issue is that now Borland C, okay, 2 megabytes of RAM was enough for it, but 40 megabytes was not enough for installation. I needed to actually do some of this thing. I don't think anyone is using it nowadays. There were something that they could compress your hard drive, make it essentially slower, but then you could have instead of 40, you could have 60. So essentially, they were compiling all the time. So I have used that one. And then these are this floppy disk. That was, I think, something like around 25 of them to install. And this is like, again, these are like things, history. But I think there were people before me that were using card punch. I didn't use card punch, but I used floppy disk. But to install it, you need to give it one by one. You will install it. When it is finished, insert the next one. And then happens that like in the 20s, it took like 2-3 hours essentially to install, say, Borland C. And then in the 20s of them, it says a bad sector. Bad sector is essentially, I think the bad sector is still a well-known thing in the hard drive. The people cannot even, then you couldn't read it, that thing. And then the whole installation was gone. Anyhow, I needed to ask the person and say, okay, let me copy it again, the same problem.
Yeah.
And this was the environment that essentially I was doing. I think at the end they got it from another 51 version. I could finally have the Borland. But I was doing Borland, and it was interesting. At that time, I was first starting, it was working with Windows 3.1 under DOS. At that time, the people didn't know that essentially you can write programs on the Windows. It was, so everything is on DOS. Why do you do it on Windows? So you needed to write it on DOS and then bring Windows 3.1 up. It takes maybe 2-3 minutes, 4 minutes, and then you will run it. And if there is a problem, then you should need to get back and go there, you couldn't even do this kind of parallel stuff. But anyhow, this was the idea that I have essentially started with C++. I think around 10, I was starting this. But after some point, I was, of course, interested in maths and IOI stuff. And that was the thing. For one of my main motivation, I asked you, Colin, about it. Why do you start this? I think for me, the main starting, there was some national TVs. And there was these people that they came from essentially Olympiad, International Olympiad. And they essentially put some kind of flower on their neck and they essentially appreciated them. That was the main motivation or incentive for me. Say, oh, can I be one of them? That was the main thing. And then, of course, among maths, I was even doing math, physics, chemistry. But because of the programming, that was my first love, essentially. And I could do the best. There were several steps in Iran. You need to, I mean, this is very competitive. You need to at least like 4 or 5, you need to pass 5 levels essentially to go to be in the team.
Oh, wow.
And just the last one, I don't know, I think here you can add it here. Like, I think it's still the case. All things was, we had essentially then 8 people was selected, essentially 4 of them were supposed to be selected to go to world final. That I was one of them. But we had something around 1.5 year just classes, essentially. And probably that's the main thing that I learned from I mean, everything that I know is from that 1.5 year thing, essentially. I mean, not everything, but most of it, essentially. There were lots of camps, essentially, and we spent time on this. But anyhow, that was my things. I think you can talk about your experience. How did you enter essentially these competitions?
I do have a question on that, though. Like with the constrained, like with how little memory you had, like did your like programs, your submissions have to be the same way? Like, did you have only like a megabyte of memory in your submissions?
Good. Okay. Yeah. So that was the thing. So I think we had so our world final was in South Africa, and then we went there. I think at that time was Compact. I'm not so sure. Compact, I think I'm not so sure it exists or merged with other things. So I have never seen so many new computers in one place, essentially. I mean, we had it in our team, like 4 teams, but there were all that was for the world final. Yes, I think they had a limitation, exactly. So the same computer that we were running, I don't remember, I think maybe it was, at the competition time was 4 or 8 megabytes of memory at that time. But a little bit, I mean, better.
That's modest, yeah.
Yeah. But I think the space was around, I don't know, maybe 120. It was, as I mentioned, they're like brand new compact computers that was in Cape Town. And all of them are new things. That was a very good thing. Yeah, go ahead.
Yeah. First of all, one verse and praise Winston. Thank you for the donations. Very awesome. And okay, so I guess my own story, like, it's not as interesting, I suppose. Basically, I mean, I heard about USICO. Like USICO is like the start of the IOI stage. It's like you have USICO, which is the USA Computing Olympiad. You have 4 contests in that, and then if you do well in that, you move on to the training camp, which is like the selection, which about like 14 people go to compete for IOI, and then top 4 in that just goes directly to IOI. So it's not like that. It's not like that big of a system. But yeah, I heard about USICO from a friend, and on a whim, basically, I just decided like to do it. And it was so interesting to me because my first contest, or my second, there are divisions. So my first contest, I solved all the problems in like an hour, which is really good. And my second contest, I solved nothing. Like I got absolutely destroyed. I didn't even get a single test case, basically. And that experience sort of made me realize like, this is really hard. This is interesting. I could put my time into this, and it seems like it could be really fun. So that's sort of how it started. I got destroyed by a contest and I wanted to do more. And then I gradually learned more. I gradually figured out how the hierarchy, like the USICO progression system works. And it just became really interesting from there. It's pretty similar. I mean, 4 years ago, it's pretty similar to how it is now. It's sort of the same system, hasn't really changed. And I guess IOI is pretty much the same too. But yeah, I suppose that's it.
I think, okay, so let me add 2 things essentially. So one very important thing is, like you see, I mean, Colin or me, I think we both had successes and But I want to say that there were lots of failures that
absolutely.
people generally don't see that. So for me, as I mentioned, I saw these people that it was like they were coming essentially back from the competition in TV. I said, oh, can I be one of them? Interestingly, at my time, there was 3 kinds. As I mentioned, in my city, there was no one who went there essentially 10 years ago. I mean, there are some of these that I have mentioned in other live in my YouTube channel. The people can see more about or hear more about it. But the one thing it is interesting. So there was each year I could compete essentially one time. So here and then it was the second. I was the second year in high school and then the third year in high school. In both of them, I couldn't get anything essentially, not even the top 60 essentially.
Mm-hmm.
And then the third one that I went, and I think in the third one, there was a camp that was selecting it. There was 30 people essentially in that camp. And I think I became 29 or 30. Later, I understood that.
Wow.
And even I think even also then they were selecting 6 essentially, 2 people from there. Like among these 6, maybe I was also number 5 or 6. But then I could actually go there and I could get the silver medal. I think I became second in terms of the ranking of the things. And interestingly, I mean, we will talk about it. So I could actually get a gold medal if I didn't make a mistake that we will talk about it. But you see, I think it is important. As Colin mentioned, if you start this competition, these are hard competitions. Yes, you will fail. That is the default. You should essentially fail enough such that next time you will. If you don't fail enough, you don't. It means that you have not tried these competitions enough. Essentially, that's a thing that I wanted. I think the first lesson if you start towards these competitions.
Yeah, absolutely. You have to kind of just get used to failure. It's going to happen. Ultimately, I mean, you can learn from it too. Like every failure is a mistake that you can learn to not repeat. So it's pretty good. Some people are requesting that you talk a bit slower, by the way. I think.
Okay.
Sure. Yeah, I think that's fine. But yeah, I mean, absolutely. Like there's so much, like failure is harsh and you'll kind of have to get used to it if you do contests seriously, but there's also so much to learn from it. So it can be positive in a sense too.
One other thing that is interesting that it is important that can help you, I think the environment. So you were in the Montgomery Blair, I think.
Yeah.
I mean, right? So that's a place actually there are lots of people generally go from that place. I mean, during years, I mean, we have also some kind of high school programming at UMD that Blair and I think Thomas.
Yes. Sort of like the culture, I guess, like just other people doing it.
The culture is very important, as I mentioned. So one thing that I lacked essentially in that sense, it was essentially this culture that the other people, there was some kind of like general exam for going to university. Everyone was going toward that. In Iran, that was the interesting thing. If you could go actually to the team, then you didn't need to pass this general exam, which was also very harsh. But then the good thing is that then you could go to any university or in some areas, of course, if you are doing, for example, computer, you could go to math, physics, and science and stuff. You couldn't go to medical. But that was a good motivation, but that was a very high risk, essentially. Of course, high reward, but very high risk. You want to go, it becomes the 4 people in the nation is always hard. And it becomes harder all the time because this number, they don't increase the number from 4 to, I don't know, 6 or like IMO, I think it is 6, but it has been 6. IOI is 4. So it means that year over year, these competitions become harder and harder. You want it or not, because they don't increase it and just the population goes up and the people know about it more about this. So I think one question that, so for me, it was like, I can mention about some of my experience that I have started actually reading some of the books. That was very helpful. So one of these books that actually I will now tell to my son, he actually loved it. He's now 11 years old. He read it maybe the early time. I think maybe he was 8 or 9 who read it. But now he rereads this book, The Concrete Mathematics. This is essentially by Donald Knuth Graham, and there was one other author that I don't remember. So it's like a great book essentially for me. There are a few books like this, a creative book, Introduction to Algorithms, a creative approach. I'm teaching actually my introduction to algorithms based on this book and of course additional stuff. But the books were very helpful. What about you? So how did you start essentially? Did you read books or you just start reading from internet?
I didn't have strictly a book, but there was a site called Usicode Training, which basically functioned like an interactive book. Like it had kind of like lectures, I guess, not lectures, but like just lessons on like the basic algorithms that you would need, and then it had some practice problems that you could submit to and stuff like that. I'll link it in chat for the people who are interested. But basically, I mean, yeah, it basically functioned as an interactive book, I guess. It wasn't strictly a book, but it was the same in that sense. It was an organized curriculum of knowledge and learning and stuff like that.
Good. By the way, I think it might be good also in the like. I think in the description of or live, if you add it, that would be good for the people because some of this information I will say maybe it is more like the history. I think I did try to present the lessons that I learned such that it can be used, but I think your versions are more up to date for the people who want to use it essentially. And again, in different countries, of course, different. But I think nowadays, in everywhere, it is very competitive. This competition, as I mentioned, it becomes more and more competitive. And also, as we discussed, failure essentially is the things to do it. And that it is correct. So the people, I mean, were reading the book maybe much like earlier times, but they are maybe reading less books now. So one other interesting thing I want to see, I mean, what is your take on that? When I started essentially, like back there, essentially, as I mentioned, the computers were not everyone had a computer. I mean, let a PC, I mean, let alone a laptop or something. There was, rarely the people had a computer. So back there in Iran, I think it might be a bit different in US, but probably not much different. But there also, the idea is that they were doing more on theoretical stuff. So like they try to essentially ask people to write the solutions essentially to the problem, more in terms of writing. Only the latest stage that I mentioned, we were there essentially around 1.5 years, essentially, we were in campus essentially. There we had, I have written computers a lot before, but writing computer programs, but not everyone has done it. Or not that extent. But we were working more on theoretical problems. And of course, theoretical problems which are very interesting to computers. And one of the actually great books here was another interesting from the book that we call it Layton's actually book. That I think that it turned out actually Layton became one of my advisors. For the people who don't know, he's actually the CEO of Akamai. He's a professor at MIT, and he's also CEO of Akamai. So he's and he is the founder of that as well. 1997. But he actually later always, these are the books that they could get the tests are coming from this book. Not everyone knew about them. Later we understood that. And we read this book. It was a great book. It was talking a lot of things about binary stuff. Like you can show lots of things that happen, like some of the sorts, for example, parallel sorts happen. Why is it correct? Because you need to write these numbers in binary and you can argue about it. And these are the things that because of that, we were reading a lot of books. I have read a lot of graph theory book, graph algorithms, like Introduction to Graph Theory by West. That was another great book essentially, or Bondi, I think that was another. These are like early books. Or like was another thing. So that was interesting. People like, as I mentioned, later it was like, oh, this was the book that we were just reading, and then later he became my advisor. That was a great honor. There was another book essentially about MP completeness and essentially computations and interactability. That was by Gary and Johnson. Later, actually, Johnson, I sent him when I was a student, like back in Iran, sent him an email, said, okay, at that time, there was early time of email. And he answered just, I don't know, maybe less than a day. I was so happy about it. Oh, he's answered me. Later, actually, he became my manager when I joined at AT&T. And I mentioned, do you remember I sent him, said, let me check my email. And he actually put that email, said, oh, by the way, your grammar was not good. So yeah. Okay, but that was actually quite interesting that these people that I was communicating with them, I think that's interesting. So that's the thing that I try to do, that if the people send me an email, I try to answer them. Or I think it is, I encourage the people. I think because that can actually create lots of motivations for the students who are sending the emails. Yes, maybe you don't have the resources to, like lots of people send me, for example, internship, I may not have that much resources or time for it, but at least I will answer it and I will say, okay, good luck finding another person or this. I think I believe in that. I think that is the part from, if you're a professor, like the people getting lots of email from interested high schoolers, or undergrad, I think try to answer them. That is very important because it can create hope for the people.
Mm.
So what about, so in that case, I think it is a bit different. So now in the US, I think I will say it's still US ACO. I think that what is the, maybe not the correct thing, like I will mention in the classes, we talked about, like before I was say SQL, but you should not say SQL in any interview because you get failed. You should say SQL essentially. So the same thing here. I will say US ACO, but I think, how did you pronounce it?
How did you, sorry, what? Sorry?
US ACO. How do you pronounce it?
USACO, I guess.
USACO.
I mean, people say USACO, people say USACO, like there's a lot of different, it doesn't, yeah, there's a lot of different possible pronunciations.
Good. So did you do anything about, like, for example, about try to prove theorems or like essentially reading more theory before writing the program? I think, yeah.
No, not really. Like I started with USACO training, and it's basically just an online judge. So you would just write programs and solve it. I didn't think about proving or like theoretical, like detaching my ideas from my code for like years. Only a while later, pretty much when I started YouTube, actually, that's when I started being able to like prove and be able to write things theoretically. It's, yeah, I sort of grew up on coding, I guess, pretty much.
Actually, that is interesting because, as I mentioned, I also started coding before actually doing this kind of competitions. But that is interesting. Actually, the people, I mean, they can write codes, and in a sense, you have the proof in the code. Like, for example, I think in IOI, most recently, they have some kind of approximation things that you may need to get. I think I know some tasks there, you don't need to get the exact solution, you need to get some approximate solution. But anyhow, or like in the ICPC, you need to essentially solve this problem exactly. Even one test case fails, your essentially program fails, and you will get even 20 minutes penalty there. Mm-hmm. So in some sense, I mean, there is a concept of proof there because you believe that when you submit this problem, essentially, it should work for all cases.
Yeah.
So what is your take on that? So how do you essentially make sure that your program is correct?
I think it's really hard to find a balance. Like formally proving, like doing a mathematical proof takes a lot of time. And I mean, that's, if you're really not sure, like if you're really unsure about your solution, I think like the more unsure you are, the more time you should spend into proving it. But like, I guess ultimately the goal is to have intuition, to not like prove your solution, but just to convince yourself that it's right. So you have to like, I guess there's a trade-off, and you have to sort of, I guess, analyze the problem and see whether it's going to be worth it to maybe take a penalty with a solution that's incorrect, but then you'll be able to submit it a lot faster, or hold yourself back, spend some time proving it and get it guaranteed accepted, but you might lose time for later problems and stuff like that. I think it's a hard balance to find, I guess, like strategy wise, and probably, I guess a rule of thumb would be like the harder the problem is, the later you on the contest, the more worth it is to prove. Because if you're really early on, like the more time you waste in the beginning, that's like, if you solve 5 more problems, you're going to lose that many minutes in penalty for all of that. So I think it depends on like where you are and where you are, not only in the contest, but where you are with your skills too.
So for a USACO, so there is no
yeah, there's no penalty. There's
no penalty there, correct?
Yeah, it's the scoring is like IOI pretty much.
Okay, so I think you can tell me it has been changed. The time that IOI, I remember. So they were giving you some test cases essentially that you could you can, I mean, some smaller things that you could test your things. Then when you are doing that, this was not interactive. So I think that is one difference between ICPC and essentially general judges that exist currently. I think thanks to ICPC, probably lots of them now exists. Versus there. So there was no online judge. You write your program, your task. At the end of that, you will submit the latest version. At that time, there was no internet. You just saved it on this particular.
So there's no judging at all. Okay.
Yeah. So you will submitting essentially this particular path in your things. Then they took your things, and then after the exam, they were testing it. They generally had this 20 seconds that you need to answer. And if you don't answer, so the timer was very important things to put it there if you are doing backtracking or other things to make sure that you don't put it 20 or so 19 some seconds that if you arrive at that time, then you should essentially, the best result, you just write it down and they will test your things. And if there were 5 test cases for each of them, and according to how many you will pass, you get between 0 to 100, like 20 scores for each of them. I think it was 600 total. And that was in IOI. I think we were talking about it. In IOI, there are 2 days of contest, each day 5 hours and 3 problems, essentially. Versus IOI, versus ICPC, which is 5 hours, I think probably 10, 11, sometimes 12 problems.
A lot of problems, yeah.
And there are 3 people who are using one computer. IOI is an individual one. Everyone is just doing one person, and generally 4 people from each country. So that is a country-wise versus the ICPC or the university-wise. The people from each university, they can go there. And then that's the thing. So, I mean, they have, I don't know, some informal, which country became first by ranking, I don't know, according to the number of medals, what are the weights that you are giving to the medal. So that's the difference between these 2 important competitions. And so there, I think their strategy was a bit maybe different because, I mean, I don't know how much different, but yeah, so you want to write a program, you couldn't test it essentially. And also, I mean, for ICPC, it is the case there's an online judge. At any time you will submit that you think that your program is correct, you will submit it. There are several test cases that if they pass all of them, then the problem is solved. Yeah. And you got the credit. If not, if one of them fails, essentially, you will get your program back and you get also 20 minutes penalties. So you don't want to actually submit lots of wrong answers because then your time essentially suffers. Mm-hmm. So yeah, so that's the general things. But I think in that part, I mean, we try to just write the best thing. So you couldn't test it essentially. You need to make sure the input output is correct. And it is a bit, can be very like essentially expensive for you, even if you don't do input output correctly. Maybe in the ICPC, the worst case, you get 20 minutes essentially. Mm-hmm. But there essentially you could lose a medal. So this is like, especially between getting a bronze medal and nothing is not anything, because you can easily, if you don't solve one problem, you cannot get anything only because of input output. But so this was the same type of things in the USACO, correct? For the contest that you have it for the selection.
You have feedback. Like it's not. It does serve as an online judge, but like the scoring is similar to IOI, where it's like no penalty. You get points per test case instead of like subtasks. So recently they've been dividing test cases into subtasks, and the cases are strong enough that it basically is like normal scoring. But yeah, it's pretty much similar scoring to IOI, but you do definitely have like the live feedback. I think in 2012 that was not the case. In 2012, and like older USACO, like it would be similar. You would not have any feedback. You just submit your program and then they'd run them all after. But recently, at least, it's been similar to IOI, but you do have feedback. I think it's really an interesting format. I think China IOI sort of has the same thing, right? They don't give you an online judge. So you sort of have to, I guess, just make sure you're doing everything correct, maybe stress test even, be sure you're proving, be sure your solution is correct. It's kind of interesting in that sense.
Yeah, I mean, I think it can test different things, I will say. A little bit different strategies you may want to do it because I think that was exactly the balance that you mentioned. How sure you are about your programs in ICPC, they say, okay, maybe if it's like work, instead you should not, I mean, especially if you care about to get the top standing, you don't want to submit a wrong program. But you may get some chances. Here in IOI, I don't, what about in IOI? Do they do it after the test, like after the contest now, or you get some feedback there as well?
I think they give you feedback, yeah. Because I mean, there's a live scoreboard and stuff like that, so people know what scores they're getting.
Yeah, that is important. You know, this is even this other thing. For example, in ICPC, there is this kind of live score that you will see which problem was solved. That is a very good guide for you. That which problems are easier potentially, and then you can try them. Of course, I mean that other things that at that time it was 3 problems, and then each day, and you don't have any clue. So one question: how much stress did you had it when you are going to these competitions?
I did not manage that well. It was very bad for me. Like the day, pretty much the day before every USCO contest, I was just like crippled. Like I just couldn't do anything because I was that nervous about it. I think in general, like managing stress, and I mean like the mental side of it is really important and also really like underlooked, I guess. Like not that many people focus on it, but it can, yeah, I think stress and stuff like that, it can be really dangerous if you don't like manage it correctly. But yeah, it was bad for me. I've gotten better at it recently. I've sort of gotten more used to contests, but when I was doing USICO, it got really bad. Yeah.
Yeah. So that is actually and another question. It was add more to that. So in the for the USICO essential selection. So was it just based on one exam or several exams?
There are 4 contests, and pretty much, I think pretty much they sum your scores and then they just take the best people from it. They don't exactly reveal how they do it, but I mean, that would make the most sense. Just some maybe weighted average of the contest performances.
I see. Of course, that's when you go to these 14 people for the camp, essentially, correct?
Yeah. Oh, yeah. The camp is 6 contests, all in 1 week, which is tiring. But yeah.
But the 4 contests, but I think these 4 contests that you are talking about, there is one level also that you need to get. I think that's my understanding. I think probably you mentioned in your previous things, but it might be good to have some kind of summary here. So I think in the USACO, I mean, to go essentially to that level, first you need to get to the bronze level, then silver, gold, and then platinum. And I think among platinum, like among the 40 best platinum, from them they are running some content. Is this the 4 program that you mentioned, 4 contests at that things? Yeah, if you can add more to that.
I mean, there are 4 divisions, bronze to platinum, but there are 4 contests throughout the year, like 1 for every month from December to March. And like you have the divisions, and they pretty much like only throughout platinum, like they only consider your scores in platinum for making the selection camp, I guess. I think, yeah, so like the divisions are sort of more friendly to like everyone, like people who aren't necessarily vying for IOI. They're sort of like in different skill levels, but yeah, for considering camp, you have to be in platinum and you have to do well in that.
Do you hear me well?
I couldn't hear for a second. I don't know what's up with that. I think it's slightly frozen.
Close some of this program that maybe you know, this is you don't expect that this happens, but it happens essentially. Yeah. Do you hear me now?
I think it's good now. Yeah. I don't know what happened. Wait.
Yes. Yeah. Okay. This is the hopefully should be good. Okay. Yeah. So okay. So can you just repeat this part essentially?
Yeah. Like there are 4 divisions, bronze to platinum, and to like for the selection camp, they only consider your scores in platinum because that's like the hard one. But there are also 4 contests throughout the month from like there are 4 divisions, but there are also 4 contests, one from each month for December to March. And like the total of those scores are, yeah, like how they decide. But they only really consider platinum scores because that's like the hardest, the most interesting.
The hardest one, essentially. And then from them, do they take the 14 or 40?
14, 1-4. There are 14 that are going for IOI, and then they take like an additional few, sort of like in their own, like there are 2 divisions in camp, like a learning division and a competing division. And they take some people for learning, and they take like seniors or people that have been to camp before to seriously compete for IOI.
Yeah, so I think stress that you mentioned, I think probably it is some of the things also you may talk more about this one in your life. It is a very important thing. Maybe it is, especially in the higher levels. Again, of course, we can talk also about the people who are doing in sports. They may have similar things, but it might be a little bit different. I don't know. I play ping pong at some professional level as well, so I can't say that there is essentially things there as well, stress there. But I think maybe in the sports, actually, it is the case that when you essentially do the sports, then part of your stress goes away during the sports, because that's essentially activity. So generally, to me, it has been the case when I was walking or I don't know, swimming or running, that reduces my stress. Mm-hmm. So I assume that, I mean, for the people who are actually doing some of these sports, this actually kills some of this stress. For us, might be a bit different. We are doing that's essentially the best exercise that we are doing. You're just for fingers, essentially.
Yeah.
So it's a bit less of the actual activity. And this stress can be very harmful. I mean, like I can actually mention maybe some of them. I had like a bit higher blood pressure, and that I think that had some effect that this contest has added to this. And like, as you mentioned, for example, of course, each of these contests, like 6 of them or 4 of them, all of them are important. Mm-hmm. But the catch is that maybe it's okay. There are 6 of them still. I have some opportunity maybe to compensate in others. When we were essentially selected from, we were 8 in the camp, as I mentioned. Fourth was a little bit general. It was 1 year for us to become 1.5 years, because the competition of IOI at that time was in South Africa, and then in Cape Town, it was generally it is in the summertime, summer US time, but there at that time was the winter time, because the winter time here was the summertime there. And so we had lots of competitions, and everyone was small. Some of them, of course, had more impact on the final things. So it was some more manageable. Of course, each of them still had lots of essential estimates. But I can tell that, I mean, before going to the contest and I said, okay, I was liking the team, I couldn't imagine that I'm going there in the contest in IOI. And then I was just imagining myself out there, and there is no second exam. It's just essentially one exam there. And if you are not doing good there, because it's like I say, then it could be bad. And one other thing, as I mentioned, in Iran, this kind of competitions were much more bold, I would say, because they were like they was in the TVs, everyone, lots of people knew about them. They brought you to do some interview after that. And it was interesting. Also, at that time, there was only one person. And still it is the case. Only one person from Iran team didn't get the medal. So given this information, when I was imagining that I was going there, and essentially one contest, and you can ruin that.
That's all at once.
Essentially. And I was even at night, I was imagining I had a stress for that. And it was interesting. When I was on the exam, just you are going there, I mean, these are the best people from the world, essentially, all next to each. I think at that time, I don't know whether it is the case here, but I was here, just next to me, actually, another person, I think it was from Israel, actually, was sitting there. And all these people were essentially just typing. And it's a lot of stress. And there it was interesting, because this is also another difference between IOI and, like, for example, ICPC. I think still it might be the case. There are some translation stage at IOI that some people may not know English well. So then there are some of their coaches, actually, they are supposed to translate it. And this is some trust in the coaches that they don't give the answer in those things. They are giving in a limited time session. They don't have time essentially for any type of cheating, I believe, as well. But anyhow, so you get the translated one, which might be not the best translation because they're giving very limited time for them to do that. And you get the English one, and unfortunately, like a math Olympiad are easier because you are talking about like the whole problem in maybe a few lines. In IOI or in the like ICPC, these are like the reading is the main part actually. You need to be a very good reader. And you need to pass English test essentially, for example, in ICPC. So you can read these problems and understand it. So that was, and then you could ask some questions actually during this time. So you will ask some questions. These questions will be translated, and I think they are given to your coach or something. There's some essentially this step of translation. And then the coaches essentially get it because these are the people who can answer you in your language. And then some of them later told me that from the question that you asked, you said that this guy failed essentially. Yeah, so like a stupid question, I don't know that you could, but I just thought like they bought the things and they could manage that stress essentially. I mean, I don't know, but I think one thing that helped me essentially, this was just too much stress because all people are there. One of the best places that, I mean, maybe I should really, I went actually to the bathroom. That was the place that there was a little bit of space for me, such that I can think about this problem. And then I will go back and essentially try to do that because I couldn't do it with that much stress, essentially.
Yeah, that works, I guess.
Very important things, essentially, that maybe somehow overlooked in these competitions. And like, I mean, at the end, actually, in that contest, it was the case. I got silver. There was one problem that I missed. And the only reason that if I solved that problem, I could get gold. And the only reason that I missed it is that because of the things, a little bit of stress, I test my problem for the given test exam. But the issue is that at that test, it had only one test. But in the actual test, you could have several essentially instances. I forgot essentially to reset the variables after the first test. That was the reason that actually I could get. So I think we wanted to talk about it, like simple mistake like this, that you forget essentially the restart. And this is like, you need to be careful. Maybe one variable you will do it, but maybe there are other variables that you need to also restart. And essentially zero. That essentially cost me essentially going from gold to silver. But anyhow, I think two things I think we will talk about it, and I think it is important that I think in your channel, I'm very happy that you have it and you have lots of subscribers there essentially. The good thing that the people will come and take essentially care about this. It is very interesting for me, like now that I'm working more in this area. But thinking is important, but stress is important. And I don't know if the people can, maybe there are some more formal way to address this stress. Again, I find it the way to go to the bathroom in the world final, essentially, IOI, that helped me essentially. But I'm sure there are better ways essentially to handle stress. And if there are some ways that the people can suggest and build some theory for this. And again, this is a bit different from sports because in the sports, you get some stress out when you do the activity. Here, we don't do any activity. And this is just maybe more and more stress actually can be created. Yeah, anything you want to add to this?
I guess I'm not the right person to ask. I really have not handled stress well myself, but I think like scientifically they've worked out that the best way to approach this kind of thing is to not care at all, like to convince yourself that, at least in the contest, in the moment, to convince yourself that I guess it doesn't matter in a sense. I mean, you should care about it. Like you should, I mean, try, of course, but you shouldn't care about it to the point where it destroys you, I guess. That's all I really know about it. I don't have ways to mitigate it, I suppose. I guess, I mean, also like the more you do it, the more you treat things like you're in a big contest environment, I guess the more used to it you get, which is helpful. But yeah, it's really hard to manage for sure.
Yeah, so just checking that everything is good. So did you? So I think we are live still at YouTube, correct?
Yeah.
So it is good.
It's something
Like testing the because this is the hardware, the software that we are using, so that would be good essentially to make sure that everything is actually working fine. Good. Yeah. So I think this is something that it is also interesting. Not every like person, psychiatrist or thing can help because it should be some person who also participated in this contest and know what is the thing. So that's the thing that makes it a bit harder essentially to see whether you can do all of them essentially at the same time and you do it. I think, yeah, that would be good. I think the team should spend some time on this one because, as I mentioned, I have a bit high blood pressure, and I think that is somehow related to these things. And this kind of competition, when you go there, there's stress remains on you at your when you are very early on, and I mean, you have lots of stress. That's essentially one thing that can have long-term effect on people, and it would be good if there are some ways, more formal ways, again, with the people who are professional. But yeah, I think one easy way you can try to convince or say it is not important, but at the end of the day, you should not ruin this and try your best. And if you bring it a little bit lower than that, you may not try your best during the contest. So that's about these things. And so I think it's somehow we were talking about the before the contest, and of course these are some of the during the contest in somehow even exactly on the contest. Stress is the important one. So one question that I have it for you that at the time that we started at that time. The best thing that we tried to get maybe some IOIs, some other contests from the different teams, maybe like selection teams from different countries that they could get it through emails. Or, the other thing is that the past IOIs, that's the thing that we try to essentially do exercise in that. So that's pretty limited. It's not that. It was not still you could try. There were some books that you could do that. There were some limited things that you could do it. However, nowadays there are huge resources essentially. The codeforces, Geek4Geeks, I don't know, Google Code Jam, lots of things.
Yeah.
So which one you should try? What is the best strategy? You cannot try all of them, and you will be. This is the stress again. If you want to try it, I should try everything. You cannot do that essentially.
Yeah.
What is the best strategy there? So do you have any clues there?
I think for the sake of IOI, like you should stay focused on like the OI format, I guess. There are a lot of like Olympiads from other countries as well, like EJOI, I think just JOI, like a bunch of things, like a bunch
there
of
are some European ones. I forgot the name, but there are some European versions as well. Or
exactly.
European or something,
Yeah, like a bunch of really hard Olympiads that aren't IOI level, I guess, but they're like good stepping stones. So you can sort of just like progress through the difficulty of that, keep learning things, have your like your sort of theoretical basis, like the book or the site that you use to learn stuff. And then for the problems themselves, you can, there's so many resources now. There's so many different OIs and stuff like that you can pull problems from. I think it's good enough to just stick to that pretty much. I think it's,
great. So I think that is actually an interesting thing that you mentioned. I think that's a good question. So if you want to go for IOI, maybe you should focus essentially more on IOI versus
like
other things essentially, and like similar essentially content. So maybe that's a strategy that we took it at that time that we were focusing more on IOI exam. That's correct. That's maybe the better strategy because first we don't have time to do that. I can actually confess there are some other things. I went to some of these like maybe interviews, I don't know, for Facebook or Google during my career. And so they have the programming essentially part. They say that, okay, if you want to prepare yourself, you need to do codeforces or something like this. I always try to refrain to do that. Okay, I have done these programs. I still, write programs actually. Sometimes I think like a few years, like maybe 1 or 2 years ago, I was writing like something for trading a stock essentially. I have written maybe around 70, 80K lines of code. Like I have done it more in Python essentially.
Wow.
So I'm writing still the things, but I try to refrain to go to this exam, like for example, codeforces or other things, because they have their things. And I say, okay, I have done in IOI, I'm writing program. I should be able to figure out the solution. And of course, in working in this algorithm, researching in this area, I should be able to figure out the solution on the exam. And I can confess in almost all of them, I could solve the problem. I mean, essentially, the programming part was somehow done. So in some sense, maybe this is the way that I think I can get it from your experience, because you have more recent, is that try, I think, the IOI or similar selection things there. Maybe if you want to try after that, if you have more time, go only for very hard problems, for example, in, I don't know, codeforces or Geek4Geeks or other things. The easy one, probably you should be good at. Maybe, I mean, you don't have time to try that. But because this level up to medium, if you worked on IOI stuff and you worked in this one, probably you should be able to solve these problems already. And if you want to do that, like, you can take time, but it's not the thing. But the hard one maybe is still something that can add to it. Yeah, go ahead.
Yeah, I think for IOI specifically, like that format that works better. Like for other contests where there's like a concept of penalty, you sort of need to be good at everything. But for IOI, where there's no like, the score is just the sum of the subtasks that you get, I think a strategy like that makes more sense, where you just need to be able to solve hard things pretty much. And speed is sort of not unimportant, but like less important. So you really can just focus on the hard stuff. Yeah, I think for that, it makes sense.
Yeah, so that would be, I mean, that can actually, it is interesting. So we will go, I mean, later to these things. But I mean, the two algorithms that I remember that I was doing for the contest. So whenever I was working essentially for IO, you know, you work sometime, then maybe for a while you take some break and then you come back. And whenever you want to get to the mode, for example, essentially programming, and especially for like IO, one thing that I tried first, these are the two programs that I was doing. I was doing the matching problems essentially on general graphs. And matching essentially, the problem is that you are given a graph network, you want to find a set of edges such that no two of them essentially share an endpoint at the end, the number of these edges are maximized. It's a very practical problem. There's lots of application in advertisements, etc. This is one of the hardest problems actually that has been ever done. This was done around 90, I think 60. This Jack Edmonds have done this. And at that time, it was this. This is one of the articles. We will go a little bit about more research things. This is the article by Jack Edmonds. That is, he's talking about this around 96, something like 60 years ago. At that time, this concept of even polynomial time algorithm, fast algorithm, was not very well known. Then at that time, and this is a simple problem again, network want to find the maximum number of edges such that they don't intersect essentially in terms of endpoints. How can you find
versus? Yeah.
Yeah, they don't intersect in their essentially endpoint vertices matching. Then he actually comes with this algorithm. It's a beautiful thing. This is essentially Blossom algorithms that this in the general graphs. It is a very hard algorithm. And especially the weighted matching in general graph still, after 60 years, one of the hardest problems that you can actually find in polynomial time that we know that. Another problem maybe is somehow the same thing as the matrix intersection, but these are like one of the hardest problems essentially in P that you can solve with this. And he would solve it at that time. You cannot imagine. The people, he was written it, so he need to motivate in the paper that why my thing is important. Why? Because the mathematicians say, okay, you want to find such a matching. Why don't you try everything and find the best one? This is the problem solved. Why do you want to do that?
Right.
It's a beautiful paper. He tried to say that why my solution is actually a smart solution and why trying all possibilities is not a good option, essentially, and getting the polynomial time algorithm. And this actually one of the early papers that actually talks about the polynomial time algorithms and do it, and others probably they talk, but for a real problem and motivated, I think he should, one of the things that I always say that actually, that he really deserves to get a Turing Award, which is the Nobel Prize in computing. I mean, there are some issues that, I mean, for him in particular, but still, I believe that he deserves it because it's so hard. I mean, to get it. And then 60 years, after 60 years, still that is one of the hardest. That means that this guy actually was very, I mean, genius to do it 60 years ago, and still we don't have anything better than that. But anyhow, this is one of the hardest problems for me to do it. It took me, but these hard problems, I have done it, of course, several times. I had the code from the previous time. I was testing the solution, but I wanted to rewrite the whole program to make sure that I'm doing the things. That was one of them. The other one was, I think, the linear triangulations. Again, these are not without using the things that are there. How you can write it from scratch without using any other procedure. You will write it. If you want to use the source, write the source as well. And that's the thing that will bring you to the mood of essentially programming that, okay, now we think I can solve other problems. So in some sense, you say the same thing that also they should try to solve hard problems. And I want to add more to it when we talk about after essentially this thing. So yeah, I think that is, so anything else you want to add it? So if you want to, what about this, for example, the bronze, like silver, gold things? They are also solving IOI problem with helps, or there maybe you want to solve maybe more, I don't know, codeforces or other type of things.
Like divisions in Usica?
Yeah.
I guess it depends on specifically what you're doing it for. Like, I guess the what is it? Those other OIs are like really hard, I guess. So if you're new, it's kind of hard to make use of them. So maybe it would be useful to have other sites like codeforces and stuff like that. But I think in general, like it's pretty optimal to just focus on the specific thing you're trying to get good at. Like for example, Usico has at this point like 10 years of problem archives. So I think there's a lot to work with, even if the other like OIs aren't going to help you as much. I think there is a lot to work with just from, for example, Usico. I think it should be. I think it would be relatively the same, I guess. If your goal is to improve at Usico, to get better at that sort of thing, then you should stick with that, I guess.
Good. So I think that makes sense. I mean, try to essentially do if you want to do IOI, try IOI. If you want to ICPC, try ICPC. If you want to do for interviews, maybe you should do those on those things. But some of them, again, might be, some of this is actually I can mention. I mentioned this time. I have seen some of, for example, this one, Geek for Geeks especially. There are some of these programs that they talk about it and they give the things for hashing and some other problems. These are actually beautiful problems. And I can confess, some of them I was reading essentially, and I don't know, for interviews or other things, and they say, oh, this is actually a nice problem. I can do more research on that. And they have done actually some research based on some of this. So I think some of them also will be useful. The hard one probably, not. If you are done with the things that you have done it, then you want to do it more, maybe you to go and do the hard ones of the other contests or these things. So another question that, I mean, how much essentially, this is the question, but how do you put it in your schedule? So I'm sure so when did how old you were that, I mean, you started essentially this kind of USACO?
Yeah, 10th grade. Yeah. 10th grade, like mid 10th grade, I guess, and then just kept doing it from there.
I see. Good. So I think like, what about the other people? Do you know that the people may start, I don't know, maybe there are 5th grade, or the typical set of people that you know is like around 8, maybe 9, but not much earlier?
Yeah, I think definitely like people don't start that early. I think something like math, it's a lot like CS is so involved. Like you have to learn how to code, you have to learn the mathematical basis and stuff like that. There's a lot more like background it takes, so it's harder to start young. And some people do. I know that. I know like some of the even the IOI contestants, they started when they were really young, and some of them like they went to IOI in like ninth grade and stuff, so they clearly got really good before that. But I think on average, a lot of people start either in middle school or in high school, probably mostly in high school, I guess, is what I've gathered. And people, I guess, carry on with that in ICPC. I mean, people start all over the timeline, I guess. I mean, some people find out about it through ICPC and they just start from there in college, and they still can do fine and get good and stuff. But
yeah, I have actually a great example of this essentially. Marek Sigan, actually, I think there was another Catalyst, was another person essentially. These are some of my, I mean, there was one was a master student, another one was my postdoc essentially. They actually got the first rank or second rank, I think, actually in ICPC, which is very hard to get. And they didn't participate at all. I mean, or maybe very limited at IOI, at least they were not in the teams. So that can change. Of course, you need to have the background and do it like that. But really one other thing that actually gives goes the credit go to Richard Peng. I think it was, I think I'm not so sure. He's actually at Waterloo or CMU now as a professor. Yeah. And he has done that. He told me that at China, again, that the way that they are doing, the people who are going for IOI, essentially maybe for a year before IOI or 2 years before that, they are not doing any programming. The only thing that they are doing are maths. And generally, this is mainly the IMO team, maybe not the same people, but the same set of people that work there, that in the last year or two, after, they don't do anything. They just do maths. And then the last year or two, they will just switch essentially to doing more programming. And then essentially, these are the people who go on, like they are the China team. I think that is one also a strategy that is some sort of the same thing that I have mentioned, like the way that I was doing at that time. So I was doing programming when I was, I'd say maybe sixth, seventh grade, I started programming, like C++, but not the IOI type. That started later, maybe I was like essentially around ninth grade that they are doing that. But even there, I mean, lots of other people at that time, they didn't have even personal computers. So at that time, there were lots of math questions that they were asking. And again, these are math questions which are related to CS. As I mentioned, Layton book is one of the things that you want to say that why this sorting happened in a butterfly, some kind of thing. You can essentially show that only if you consider, if you show the binaries, the numbers are binaries, you can actually beautifully show how does it work. Otherwise, you don't have any clue why does it work, essentially. I still actually, this is the book I think, I was talking with him, I think he was supposed to get the second or third version, but I think he was just become very occupied with Akamai from 1997, 1998. But I think that's a great book. If you find it, I think it's a good one, very good one to read. That one, Concrete Math, Introduction to Algorithms, essentially, by Udi Member, A Creative Approach. That's also a beautiful book, essentially, to read and the way that is thinking, essentially. So, one other question is that, like, this was other thing that I have mentioned. So when you started, how much time you are spending on these things? Like you don't know whether you will get it, the final things. If you get it, I think in US there is no guarantee, but generally if you get it in the, I mean, that level, even the, I don't know, 14 level or something like this, let alone if you be the 4, you can typically get in a very good university. There are people that they especially care about this and they try to admit you. But there's no guarantee, essentially. How do you take the risk, essentially? Because if you don't get it there, maybe it's not there.
Yeah, risks like that are really hard. Like, I think initially I did it, I didn't have any serious intentions. I did it just because it was fun, because I wanted to get better. And that was my most serious, like starting off the first like 3 months, I guess, was the most serious time. Like I pretty much put all my free time into it. I'd like finally found something that I could just do pretty much. And then later on, it became more serious, and And as it got more serious, it got harder to practice, I guess, which is, I didn't put as much time into it, I guess. Like I would do it sometimes throughout the day, I guess. It was like, I guess, on average, like a couple hours a day. But in the very beginning, it was like many, many hours all at once. But I guess on average, it would be just a couple hours a day, I guess, solving some problems that were relevant, getting better at. I guess my main target was codeforces, and then IOI was kind of its own thing that I didn't, I guess, give that much precedence to. And that sort of made it, I think it's easier to focus on something like codeforces because like it's not just a single contest. It's like something that you can keep doing like forever. So there's less risk involved, which is nice. So having that to focus on, I think is easier on the mind, I guess. But
I think that's actually a good point that you mentioned, because somehow you try to minimize the risk. How can you minimize the risk? Make it essentially some kind of not 0-1, make it partial. And I think, as you mentioned, codeforces is a good thing because it is a very well-known thing. The people know that nowadays they should care about your ranking there. So essentially, any work that you are doing, it is something that you are investing on your codeforces, essentially, ranking. So it becomes, yes, you may not get the top thing, but it's like being, I don't know, the top 100 or top 10 or this still is like a very great achievement. So you may not get even the top thing. So in that case, is it the case that you reduce the risk by not essentially doing these things? And it is especially important for the US university because when I have been like in admission, both grad and undergrad, this you may not get essentially the top one, but the fact that you can put a still in your CV that you have been in such a rank essentially in codeforces or other things. And that will help you a lot because later, I mean, that is something that can help you essentially to get admissions. So did it affect other part of your life essentially? For example, I don't know, that at the time or like the other part, did you have enough time to do sports or I don't know? What about like your other courses like chemistry, physics, and other things? Did it had any affected by this or?
I didn't really do sports honestly, so it wouldn't have blocked me out from doing that. I school-wise, like I admittedly was solving problems in school, so it was kind of distracting me from that. But like I think academically I got by. I mean, there was enough time to do both practice and like, do homework, finish my class stuff like that, and be able to focus on school too. So it didn't really like it didn't hurt, I suppose. Like there exists a balance that you can find where you can get both done and still have a lot of time to put in.
Good. So I think that is good. I think that was interesting for my side because, as I mentioned, for example, there to get a university at that time, I think it is the case here. There was one way that if you go and you become the people in the campus essentially, that they get nationally gold medal, which is the people who go to the campus essentially. There you could go to any universities. Otherwise,
I know something like that in China too, where they pretty much if you get a medal in IOI, I think they just guarantee you admission. That's US doesn't have something like that, but
in US it's not, I mean, not everything on the fly, but generally if you write to a professor who had experience in this one, you write it. That can help you a lot in general.
Yeah, it should
because
definitely.
The people who know that, and if they know this person, I know this is a very high level. You should really give admission to this person, etc. That's actually the way that works with lots of my graduate students as well. That they all have actually participated in IOI or essentially ICPC as well. But so that's one thing. But also, I mean, that time it was interesting that then I needed to, this kind of general test that you need to do it. It was very competitive, that one. The people spent 3-4 years essentially and had all these courses. And it was interestingly for me to do the risk. I was very good also on the other courses, but you need to prepare for those type of tests as well. And I decided to go with this, but very risky, because if I couldn't get the gold, even silver was not enough, and I need to go there. And they have much limited time essentially to prepare there. So I could essentially end up in nowhere essentially, or not a very good top thing. Like in Iran, it was the main thing, go to Sharif University. That's the thing, the best university in Iran, essentially in the science and math, I will say. And that was super important to get it there. But yeah, I think that is good. In the US, everything is more like a smooth version of that. So yeah, you can get it. Maybe if you don't get it, not a big deal. You can still mention your ranking in codeforces, and also you do your other stuff and get the things.
Yeah.
So this was another thing. I think the question, like during, or I mean, essentially this is before and during this. How much? I think this is one of the things that I know that you are talking a lot in your YouTube channel about thinking versus coding.
Yeah.
Yeah. Give your, I think, the short summary there. I will add more to that.
Like I personally think that thinking is, I guess, a lot more important, because I guess, yeah, I guess it really depends on what you're doing. Like there's been over the last 2 years, codeforces in particular has shifted to like, it's shifted to a lot of like ad hoc, like more mathematical, like more sort of abstract things that are, I guess they don't like, for example, data structure problems and stuff like that anymore. They like things that are easy to code and hard to think about. And maybe probably IOI and ICPC are still sort of on the coding side. So I guess for that, it would also, it always depends on like what you're trying to do. But I think no matter what, like thinking is really important, because coding is sort of like thinking in disguise, I guess. Like coding is being able to take these thoughts that you have and turn them into something concrete and then type that out without screwing up, I guess. So I think if you are good at thinking, then like it should be a lot more helpful, I suppose. Like you still need to be able to code. You still need that skill. But I think thinking is a lot harder to train, so it deserves more of your time, I suppose. What would you say on that, I guess?
Great. So I think that is exactly, I mean, if this thing that we talked, we mentioned from different, I mean, I mentioned, for example, from Richard Peng or other things that I have tried. And I think all of them essentially emphasizing on that part. The thinking is the main part. So, and it becomes more and more the main part. Coding is important. You need to be good at coding. Like one of the things that you should try essentially enough. But maybe for that, actually, you can put some time, and then essentially becomes good. And again, data structures are still very useful, for example, in IOI or in the, as you mentioned, ICPC. But the issue that this thinking becomes more important. And I have actually a bit more philosophical things to add to this. And this is one of the things that I try to actually, this is the one message that I want to do, that is that spend more time on thinking, and that is something that you can do it after this contest. And this is the one, actually, I was also talking with Professor Bill Poucher. I mean, he's actually the founder of ICPC. If you go to my YouTube, actually, that's the one thing that I have mentioned. That this is also one of the things, the issues that I had with ICPC, that I will, some of the critics that I have also mentioned to him. Actually, he also said, okay, that's good, actually. We should spend more time to have these things. But I think they are important. Why? The first thing is that the coding. We are now living in the era of ChatGPT and Copilot, for example. And you will see from very top people who are like the very founders of big companies, and they are like very technically strong. They say that 80-90% of the code are written by this software, essentially. This is, of course, autocomplete, but some of this that you can do it there. Yeah. Maybe in IOI world or these other things, it is a bit of less of these things. But I will say that, I mean, I was talking with some people at Google. He was in the NLP and essentially AI, ML for NLP. So, and that was, this is the part, like lots of OpenAI saying that company that actually has the ChatGPT, they went from Google. So Google is like natural language processing, or AI is this one. It was very strong. I was talking with one of these people, and he said that we didn't expect to have something at the level of ChatGPT before 2060.
Mm-hmm.
So the person at the heart of this technology said that I didn't expect it. And we are in 2023 and we have it.
Yeah.
So the technology is going super fast essentially.
Mm-hmm.
And this is one of the main dangers that people are talking about, is that, okay, the robots can essentially do, I mean, then this, and there are lots of replications of already this for the different aspect of the things. And it is like amazing ChatGPT in writing essentially, as well as in writing the codes essentially for it. And given that, I think one important thing that, again, there are some philosophical things I don't want to, I mean, I have mentioned some of them in my YouTube things, but these are like the issues that at this time, like, we want to be superior to these computers. And this is the only part that potentially is still, I don't know, it can be still kept at this level maybe 4 years from now, 5 years from now, I don't know, 10 years from now. But at least, I mean, at the current time, these are the main problem that they cannot do it. These are the problem that they are essentially needs a lot of thinking. Yeah. So that's the main superiority that we can have it to this computer.
Yeah, it's really complex.
And not only that, I mean, the people who want to hire you, maybe if you want to go to these top companies, or like you want to also go in academia, they need to see you that you are solving these problems, the hard problems. Hard problems need essentially more thinking. Yes, it is good to know about dynamic programming and the different things, but doing 10 times of dynamic programming, very similar ideas to each other, maybe is not the most fun part that you want to do it anymore. And anyhow, this contest also try to give you some programs that they are not exactly like similar one. You need to have more novelty there. So thinking is the super important part.
Yeah.
And this is the one that actually I wanted to emphasize on that. So when you learn these things, and again, I think these are all of this. We talk about all this math problem that you may want to do it, and then last 1 or 2 years you want to do this computer science, or this is the thing that you mentioned, that codeforces become harder. I want to add actually more than that. And that's one of the main messages that I want to have it here, that if you work in this area, and also the thing that you mentioned, to get stronger, you really need to solve harder problems, not just the same type of problems. And this is the part that comes after this competition. What is the idea? The idea that, okay, you will go there. At some point, you want to be the best programmers in the world. I think there's one person, he was in this ICPC, the national level. I think he's probably the most decorated person in terms of the IOI and ICPC. I forgot his name.
Tourist, probably?
Yeah. He's like essentially, yes, there is this one that you can actually be there. But this is the next level. This is the one that I want to actually put more incentive and encourage for audiences who are listening to this. That, okay, at this stage, you may say that you want to solve some problems, that you want to be the best programmers, like IOI, ICPC, etc. That is great achievement, and you should do that. But while you do that, at the same time, there is also one other thing. The issue is that this problem, generally, some people, at least one person who designed this problem, who knows the solutions, can we go one level higher? Solve problem that no one knows the solution.
Yep.
And that's exactly the one that I want to go, like, after these competitions. I think you should focus on it. And this is one of the things that I give you some of these examples of this problem that you cannot believe that these problems, you are solving this problem all the time, and the whole research community, and this more, I will say, theoretical computer science or the algorithmic field essentially. I mean, nowadays algorithm is used for everyone, all this NLP stuff. Great, these are more hacking. That's some of the more hacking essentially that you are doing and you are publishing in even the conferences or used in the company. These are great. I have spent a lot of time on this one. And I have even actually some of these things on the potentials of e-commerce. We have some series that as like a person who has like more theory background, they have went there and tried to understand them and say that some of these type of algorithms are very useful. But I think for the theoretical computer science, we have several of these people. I can just name a few. I mean, please forgive me if I just, for example, Shayan Obeid Karan, he actually started some of this work with me, but he has a gold IOI medalist. Moses Chalikar. Another, I mean, he's actually a professor at Stanford. He was in the IMO. Another very, I mean, famous person, Peter Shore. Actually, I had also a live, I have a live with several, I mean, essentially famous computer scientists. We talk about this one. I say, what is your background now? And these are like general computer scientists, not just theory, but the areas. I think I encourage people to just go and watch it. I think it was, I learned a lot from them. So I was talking with Peter Shore. I mean, he actually had a silver medal in IMO. And he has these Shore algorithms, and he's actually using some kind of number theory, essentially, on addition of other things. But you can see actually this, he helped actually him to think about this IMO part to such that he has such a great algorithm. Essentially, he got tons of awards after his silver medal in IMO. And he got actually his PhD with Tom Layton. We are like academically brother, actually. And he has done this thing, and he used these ideas, and he has this algorithm that this is like the most famous algorithm in quantum computer world, Shore's algorithm. And if you see that, you will see these ideas. I mean, what is that? Essentially for factoring. So if you want to factor essentially a number, currently in polynomial time we cannot do it, but with a quantum computer we can do it actually better. That's one of the most famous things. He got lots of awards essentially. I mean, for this one, like he got the Nevalina Prize, he got his breakthrough award, and other things, mainly because of essentially this background. And this is the main thing. So I think we should, I mean, anyone who is working on this one, we try to think a little bit harder and maybe see that, okay, I have all these things. Let me think about a hard problem. And again, this is one of the things that lots of my students actually have all participated. They have several gold medalists. I had it in my team, silver medalists and others, essentially national goals among other from different countries as well. And so this is super important actually to spend time and then say, can I solve some problem that nobody has solved? And change problems essentially that exist. I will mention some of these things that actually might be just one of them, for example, that we don't know. So we all know about all pair shortest paths. If you want to get all pair shortest paths, then I mean you can do this Floyd-Warshall, these three loops that you will do it. And it is super important that you don't miss the order of the loop. Because if you more there, this is one of the typical mistakes that we want to talk, and then essentially everything will be wrong if you just change that. And actually, it is interesting that why, if you change the order, it does not work exactly comes because of the proof that why this algorithm works into it.
Yeah.
So we know this n to the 3. That's probably lots of people, if you want to implement some all pair shortest path, they just use that. One of the great open problems that we don't know, it is like you cannot believe that. Can we do this one n to the 3 minus epsilon? For some, can we do it? We can do it. Actually, there's some algorithm. It is we can do it n to the 3 over log n or something like this. But can you do it n to the 2.9 something? 2.99.
Just anything. Yeah. I see what you mean.
That nobody actually, we don't have this one. Now, interestingly, of course, we don't have it. The people, and this is interesting. I mean, several people actually, as you mentioned, there are some people that maybe didn't work in IOI, but now they are working in this. And there are lots of researchers that they have some work on similar problems. For this one, we don't have the problem. Now, let me tell you another super interesting problem. So this one, the people couldn't solve it. It is known in the computer science, like in the complexity area or the hardness area. Anything that you cannot solve for a while, you cannot prove that you cannot solve it. Unfortunately, we are very far to prove anything.
Yeah.
The only thing after some time that you don't solve it, then it becomes essentially an assumption. Actually, I have a class, Introduction, Algorithmic Lower Bound, and we have this book with Eric Demain and Bill Gassarge about algorithmic hardness, fun with essentially, I think the book is Computation and Interactability, a guide to the hardness, essentially. You can just go hardness.mit.edu, you will see the book. I have also all the lectures of this course that currently I'm doing. I'm putting also introduction to algorithms and other courses in my YouTube channel, such that everyone can use it. And I mean, you just go there, you see type of thing that people they know. These are like trivial algorithms, and no one can do anything better. And again, the idea is that if so far nobody could get all pair shortest path better than n to the 3, then assume that n to the 3 is the best. Okay, and this was, I remember in 2002, I had actually some course. Eric Demain was another, I mean, like my co-advisor actually. And he was teaching this one in the class. And okay, this simple dynamic programming, we don't have anything better than that. Can you get it? 20 years after that, still we don't know. The only thing is that now the people, it is called fine-grained complexity. So they assume that, okay, n to the 3 is the best.
Yeah.
But, I mean, we don't know whether it is the best. I mean, nobody has done anything and we don't have any idea. It is quite possible that we are wrong, essentially. Maybe not enough people tried or not enough smart people tried this one. I mean, it's a hard problem. Lots of smart people tried, but still more people can try, especially the people who are preparing for themselves for this competition. So this is the assumption. Now, this is another problem, which is, this one actually, still we don't know the answer. It is this is still not assumption. As I mentioned, what are the assumptions? The people tried a lot and they still couldn't solve it. So they will call it assumption. Now, based on this assumption, if I believe that APSP is hard, what other problems are hard? One other problem, I cannot do it better than cubic time. That's the type of thing that we are talking about, this algorithmic lower bound course that I mentioned, or the book that I have mentioned.
Like reduction, stuff like that?
Yeah.
Like,
so now the interesting thing, so this is even, now the diameter of a graph. So how can you find the diameter? It's the two vertices that they have the largest essentially distances. Of course, if you have the all pair shortest path, it is a very easy one. It is n squared. Go all pairs and find the longest.
Yeah.
So, trivial. This is another beautiful problem. And again, this is still not yet assumption. So it means that there is a hope that actually some people looked at it and still nothing. But now it became a big problem now after 10, 15 years. Can you do diameter anything better than this n to the 3?
Right.
If you have all pair shortest path, you can do it. But can you find any way get n.2.99 essentially for this?
Yeah.
No clues. So we don't know, essentially, this is the thing that I mentioned. So we know all pair shortest path is the assumption is n to the 3 is hard. Can you do anything essentially like that for other? See, based on this assumption, there are some other problems that you can show they are hard. But then you know that these problems are hard, this APSP. We don't know the exact relation of APSP and diameter. We know that the diameter is easier than APSP, but we don't know whether it is equivalent. Like maybe you cannot. So you see, I'm asking the question. Not only that you can get, maybe if you can get n to the 2.99, already great result essentially. But let alone that, say even you cannot do that. Can you show that it is as hard as APSP, like all pair shortest path? That we don't know even. This is like a beautiful problem that, I mean, you have this, and it's not a huge knowledge. I mentioned, I mean, this is one of the things that I have done with this, my YouTube channel at Hajiaghayi. I tried to essentially put it this kind of, this was the thing. I have been in IOI, I have working in this area, I don't know. I got it in 1997 and went there. Now it is, how many years? Almost 25 years, if not more, I think 26 years essentially. I tried to get this knowledge and to put it in some simpler things that anyone who can just essentially, like maybe some people say, okay, maybe I need to read lots of papers. No, lots of this, I mentioned this one. This is the excellent state of the art. You can just read from the book, of course, but also there are the videos that I put in there. And then there are more courses that I put in there. These are beautiful problems that you can actually read a little bit about them. You have the knowledge because you've worked a lot on this type of problem. Can you do anything better? And I think you really need some help from the people. I think this is one of the things that I have mentioned actually to Professor Bill Pacher again, one of these live videos that, okay, why don't we just do the same set of problems, lots of a different type of dynamic programming? Can we put like a little bit more harder thing? You rightly mentioned that, yeah, I mean, he actually encouraged me to get involved to try to do that. I mean, try to add more of these problems that maybe we don't know the solution. And this always happened, these all stories that we know. I mean, this great mathematician, somebody has written the open problem on the wall, and he then 2 days later he went and solved it because he didn't know he was thinking that was an exercise, not an open problem.
I've heard of that story. That's funny. Yeah.
So, and these are the great things. So these are several of these problems. So this is the one that I have mentioned. So generally, these are like in the classic algorithm, as I mentioned, fine-grained complexity, like linear time algorithms. How can we do anything better, essentially, this one? Another thing, for example, in the approximation algorithm, I think these are the things that also it is used in IOI. This is another great problem that I can tell, essentially. Nobody knows the answer. So you're given a graph. This is the Steiner problem. Steiner tree is the one that you are given a set of terminals, and you want to, each edge in the graph has some cost. You want to buy, or in the network, you want to buy a set of these edges such that the whole graph is essentially all of them becomes connected. Correct? It's like clear problem. So these are some of the terminals are given. Not all vertices. If all vertices are given, then it would be the MST problem, the minimal spanning tree problem. Here it is a Steiner. You are given some point, you want to buy a set of edges such that everyone is connected. This problem is essentially rooted in like 1800. The best approximation algorithm, this is like, it is like 1.39. If you want to get a two approximation, it's very simple. You will just do the metric compilation of this graph, means that between any two vertices, put the shortest path in the graph, and then find the MST only on this set of vertices. That gives two approximation. It was a big open problem. Can you beat two? And currently it was beaten in series of work. The latest one is 1.39 back here, I think it's like 2010. Generally, Soda Fox stock, these are the top theory conferences, like this algorithm. If you have a novel algorithm, you want to submit to this one. If you beaten the board, you want to publish there and possibly get the best paper award. This paper got the best paper award because it was improving the other things. It's simple, a generalization of that. It is, say that instead of you want to connect everything, so you are given some pairs. So this is S1, T1, S2, T2, S3, T3. And you want to buy a set of edges in the graph such that S1 is connected to T1. S2 is connected to T2. S3 is connected to T3, and so on and so forth. Correct? You don't want to connect everyone to everyone. You want to connect essentially the pairs that are given to you, and you want to just connect these pairs. This problem actually called Steiner forest. For this algorithm, nothing better than a factor 2 is known. It's a beautiful problem. And no one knows anything better than factor 2 for this problem. I think this is, and again, you don't need to have the super knowledge. Lots of this, as I mentioned, this thing that I will put it in my YouTube videos, I try to put it, I will add my all graduate courses also the thing. Because I wanted the people, this is the educational thing. If you work in the IOI, I don't know, codeforces and others, come to this problem. These are the problems that they can give you the great prize. This one, you get the best paper award, for example, in stock. These are the top theory conferences. You get the best paper essentially in the world, essentially this one. And this is a huge recognition that you can have it. As I mentioned, for example, for Peter Shor, this algorithm, by itself is so important that 30, 40 years there, he gets lots of awards because this algorithm that he designed, I don't know, a few years ago, and you can actually go and see my live with him. He talks what was the story even to get this result and work on that one. So that's, again, some of these things that I have done with this great scientists, such as you will go and see their experience. Lots of them actually, some of them had, lots of them, they didn't have this background that some of you may have it because you are working on this kind of competitive programming. It is great to come and think about these great problems and try to solve them essentially. Another interesting thing I want to say is, I just want to say these basic problems. So this is the matching problem that I have mentioned that, okay, you want to find the maximum number of edges that none of them, they share any entries. There is a simple two approximation for these problems. What is this one? It is called maximal matching. This is the most trivial thing. And again, even the edges are not weighted. consider edges by any order. If you can add it to your matching, add it.
Mm-hmm.
This is a simple two approximation. It's very easy essentially because you can say that each edge of the optimum matching can kill at most two of your edges here essentially.
Yeah.
So or vice versa essentially, and you can get a simple two approximations like very easy. One of the most important things that we have in theory, can you do essentially anything better than, for example, so what is the space that you need for this algorithm is order n. This is the space that you needed, order n. And this is some other type of algorithms called streaming algorithms that you cannot save the data, so a space becomes very important. The question is that can you get anything better than two approximation, 1.99? The catch is that you don't have a space to have essentially, and you will see the edges essentially one by. You don't have the space to keep all these edges in your the maximal matching, the solution. Because how do you do that? So you need at least order n, because the previous edges that you have chosen in the matching and there are order n of them, you need to keep them in their space in your memory. Can you do anything when you have sublinear memory? Better than two. It is like you see, isn't and interestingly, actually, this is like, for example, one of these problems, this price collecting Steiner forest. This is some generalization of this problem that I have mentioned, that if some of these pairs they have a penalty. The one that I mentioned in Steiner forest, you want to connect these pairs, and if some of these pairs you are allowed to do not connect and just pay the penalty. Mm-hmm. It's called price collecting Steiner forest. This was a big open problem essentially. Like for 30 years, can we get a two approximation for that? And we had actually a set of people. These are all, some of them actually, like Mohammad Hajiaghayi, that was your team. All these people who are working on IOI and essentially IMO, they were working, and this algorithm was open. The people tried, several famous people worked in it. They couldn't get this one, including myself. But I mentioned to them, see, I was alone, I could get it. The previous algorithm was 2.54 approximation. Like this is how many times the optimum solution you have. I told them, okay, I solved it, I had this one, I don't know, 2006. You are better than me, you are much younger, you can beat me.
Right.
Actually, 2 weeks they came with a solution that not only me, lots of other people thought about it, and they could get a simple two approximation. So I want to say these are all possible, especially if you work in this one, because you work in some of this, and you can actually come and add more to this type of things. And this is like a beautiful set of problems that you can work. It is another problem. It is also super important in finding the Nash equilibrium, essentially. So these are a set of problems that for them, we know that there exists a solution. So there are existential ones, but we don't have any polynomial time to solve them, essentially. And this is like, for example, the Nash equilibrium is one of them. There is another one, essentially. This is I forgot things. There is a fixed Brar theorem. That's another one. But all of them, for example, these are like, this is the simplest version in this category. It is called p-pad complete now. What is the category? This one. You are given essentially a directed graph. Each edge has at most one incoming and one outgoing. Mm-hmm. The simplest graph that you can imagine.
Right.
Then you know that I give you a vertex of degree a vertex of in degree 0. Mm-hmm. Good. So this is the graph. It's essentially directed thing, and then I will give you one vertex of in degree essentially 0. You know that there should be one vertex of out degree 0 in this graph.
Yeah.
Correct? Because, I mean, you know that either would be a cycle, but it cannot be all the cycles because I gave you one vertex of in degree 0.
It has to be cycles or paths, right?
Exactly. So either everything is cycle or path. So if I give you one vertex of in degree 0, then you should be able to find one vertex of out degree 0. Mm-hmm. The question is, can you do, essentially, this is the main, can you find, this is the existential. Nash equilibrium is essentially very similar to, this is in the same class. We know that there is a Nash equilibrium, mixed Nash exists. The question is this one, for this problem, can you do it anything better than order n? Running time to find that vertex. Mm-hmm. Can do any type of binary search or binary tree or like, I don't know, anything you can do it. And even not even log, I will say, n to the 1 minus epsilon. Can you solve this problem essentially somehow? A little bit better than this. Again, this is a beautiful problem. And all I say that lots of this problem that you mentioned, actually, this is the codeforces things. I think this is the correct way that they are going. These are exactly the problem. Lots of thinking is needed. This algorithm that we had, for example, for this price collecting is very natural algorithm. The issue is that, as you mentioned, so maybe if you want to write essentially a program, you will implement this algorithm, actually. The only thing is that, I mean, how can you prove, get some insight that why this works essentially? And again, the proof in some sense, these proofs, some of them are, yes, that is correct, that some of them coding and getting the actual proof might be a bit different. But if you have a good intuition, there is not much of big difference between these. Your intuition should help you to find the solution. And the most interesting thing is this one. Lots of these problems, the end result, there might be some maybe complicated things at the middle. At the end, lots of them, they came very simple algorithm that we couldn't analyze. And this is essentially my message, especially because the people are working on that. Yes, I know some person wants to do that after college. This person is going and they try to do it because he or she wants to get essentially a job at Facebook. He or she needs to do some of these codeforces or other things such as you can pass this. But which is like he wants to do some ML stuff and other things, but it's a valid thing and the people are doing it. But these are tons of people now around the world that they are doing is this kind of competitive programming. They try to be, these are starting from middle school, higher school, or even earlier. And then this is the thing that when you work on this one, just think a little bit about harder problems. And you can actually write and the background is not much more. Some of them, as I mentioned, I try to put lots of them actually in my YouTube things. But there are other videos by other professors as well that you can actually read these ones and understand the whole area, the best work that has been done. And one of the most important things, again, don't be confused. There you might see some very complicated program for this simple problem. I can tell you, 80% of the time, 90% of the time, that complicated algorithm was the wrong solution for this. You should come up with a simple solutions that actually you can beat that algorithm, and they're very simple, beautiful, and they will appreciate you. And you want to become the best programmer in the world, it is hard, but you can be like one of the best person, essentially smartest or beautiful mind in the world, because nobody could solve this one. And as I mentioned, the people who are attacking this, I would say a good fraction, they didn't have the experience that you had it, or me had. So yes, there are some of them, again, mentioned, these have been solved essentially by, like for example, for TSP, or that the person who has done it, he has the gold medal essentially in IOI. But there are lots of other problems that these people, again, you need to find the right problems. That's my job. I mean, that's the thing that I try to do it in some of also in these YouTube videos that I have it with this famous computer scientist. Always there is this part of open problem that I had it that, okay, this is the open problem. Like this is some in theory, some in non-theory. This, if you want to have a startup or something. What are the important things in the VR, virtual realization, or I don't know, robotics? What are the things? Can you find this one? But also lots of them is, for example, this Professor Nogalen. He mentioned some of the beautiful problems that you can actually think about them. Just think about them. This is the one that I mentioned always to the students. You may not solve them. Yes, that is a possibility. But at the end of the day, you are doing all the time. You are thinking about some problem, you cannot solve them. At least if you couldn't solve this problem, you know that no one in the world solved it. And that was exactly the thing, the discussion that I had with this Professor Bill Poucher, that, okay, we should have more of this, because all this beautiful mind that they are coming and they are solving these problems, if we can give them, essentially provide them in one level higher, we have essentially much better things. And one of the most important problems essentially in the world is P versus NP. Or we don't, not only we cannot solve this problem, as I mentioned, nowadays it is like that in in like more theoretical computer science, we are very far from P not equal to NP. I think probably the people that they invented P not equal to NP at that time maybe said, okay, maybe in 30, 40 years we can solve it. Probably at this time, is the current speed, I will say that I will be surprised even in 100 years essentially we can solve it. Unless some things like ChatGPT and other they are doing some advanced, they solve this problem. So essentially we became much further, I will say this. And again, I think these problems, I think still we have a time. I will mention to my students, let's solve some problems before humans essentially mind becomes obsolete versus these machines. They can solve any problem because those machines, I don't know, I want also have this thing that hopefully if they have some a little bit of integrity, if they have it, they should refer us as the early humans that they could, or early smart people who could actually solve some of these problems that they could build on. Mm-hmm. But I think we have time and we have lots of resources. And again, some of this I try to put it in my YouTube, but it's not just me, there are some other people as well. I try to put some of this basic stuff such that the people will come. It's the same background that I had it. I'm a programmer. I started with C++ programming. At that time, I was doing, at that time when I started, you cannot believe one of the main projects that I have done, I tried to put essentially menu. It is trivial now, but it was not if you are working in the DOS. In the DOS, having nice menus in this slow computer that you will do it, you can go back and forth with the keyboard. It's quite non-trivial. You cannot believe it. That was one of the things that I have written this one on the hard, essentially in the graphics card. You need to write it in the graphics card directly, some assembly, etc. involved, such that you can write it. I have started with this background. I have worked on some of this robotic things. This is called essentially Robocop. I have written programs, the best goalie of that year, I have written it. All of them, but at the end comes from these algorithms. And they have, written some of algorithms that are in the top companies, Google, Amazon. There are lots of people, they make millions of dollars for this company. But still I advocating that if you work in this area, come and try to increase our understanding about this theoretical computer science, because these are very fundamental problems. Like you may see, for example, about something about neural nets, the deep nets essentially. But at the end of the day, these deep nets, it has several components. It has the shortest path there. If you can improve that shortest path algorithm there, you may not see it, but this has been done essentially there. If you can do this shortest path, improve it there, then you are improving the state of the art in AI, in ChatGPT. That's the thing that, but just don't essentially, I think, put the aim higher and try to essentially do this one level up and try to find this problem at one time. One thing that is important also, writing. I can just mention about writing. I think it was one of the things I wanted to add. The difference between writing and coding. Now it actually became much less. Again, thanks to ChatGPT. If you are not a native English speaker, if you write any gibberish things, at least there are some ideas. Just give it to ChatGPT, make a beautiful sentence for you.
Yeah, you could. Mm-hmm.
And this, not only this, I'm working with some native English speakers, with some professors, and still ChatGPT can beat us with the better word. Why? Because we have our own local brain that we will find the best wording for this. ChatGPT is doing the whole World Wide Web. That's essentially the whole idea. You just need to search over liner thing and find better sentences for us. Mm-hmm. So that writing actually, you need to, I try also some of these videos, I try to also mention about this, that how you can prove it, get the idea. It's not that much different from that intuition and writing the algorithm. You generally need to write your algorithm, explain what is this, and then step by step say that why your intuition is reasonable, maybe adding a bit more details. Yeah. But I can confess, like when I came essentially 2000 actually I came to Waterloo. I got my master. I think I have my master thesis about some, this is another problem actually, this by the way, very important. We don't know the solution. Graph isomorphism. This is two graphs the same size. And we want to see that can I find a permutation of vertices here to there, such that these are the same graphs. Mm-hmm. It's a big open problem. It is not also it is not an NP hard problem. We don't know the answer to this. So this was some version of that subgraph isomorphism. I was thinking that I have written the whole algorithm, this new advancement. But then I mentioned I was essentially for 4 or 5 months, I was just rewriting the same algorithm, just essentially, because writing takes time. But currently, thanks to ChatGPT and some of these resources that exist, you should know how you can turn your ideas little by little, the intuition into proof. But writing it, I mean, things is not an easy thing. But with ChatGPT, actually, you can do it much better. You can just write some, as I mentioned, simplish things, and then makes it nice things. And then you can just do it iteratively and improve it.
Yeah.
Adding some figures. This is the thing that you can actually send it to the top, essentially, CS theory conferences. And then actually you solve some of these big problems, you get a big prize. So this might be a shorter way, essentially, for some of us, some of you that we want to work on it, just go there and solve a few of these important problems I solved it. And this was not hard. Again, lots of them, they have a simple solution, just we may not know that solution. At least 80-90% of the time it was like that. So these are some of the things that I mentioned essentially I wanted to go from this to this. So what do you think, Colin? Anything I talked a lot on this part, yeah.
Like on the subject of open problems, I guess?
Yeah.
Yeah, I mean, I think it's really, in terms of it being a next step, I think that makes a lot of sense. Like as sort of progression from programming contest goes, like it is, from what I've gathered, these seem kind of similar. I mean, like stuff like tree isomorphism is a lot easier, of course, but it's the type of thing that we solve. And it's like there's a really, really strong correlation between these like theoretical unsolved problems and the problems that you do get in competitive programming and stuff. So I think it's definitely good preparation at the very least. Like you get practice thinking about algorithmic concepts and trying to come up with algorithms and proving their correctness and stuff like that. So there's so much like overlap in that whole thing pretty much.
I think exactly as you mentioned. So this is, and the gap is essentially because, so for example, this is also interesting. So this is like the way of research. So this graph isomorphism, okay, we don't know the solution in polynomial time. There was a great achievement here, actually, by Laszlo Babai to get it essentially sub-exponential. What's the meaning of that? Instead of like essentially 2 to the n, try all possibility.
Has that been done?
A little bit better than that. Maybe 2 to the SVR root of n, for example. So 2 to the n essentially means trying all possibilities, essentially, or n factorial, which are the same, essentially. 2 to the n like that. Can we do a little bit sublinear, like sub-exponential, it is called, 2 to the SVR root of n? This was a great achievement by Laszlo Babai a few years ago. And what is this? This is actually, there is a field called fixed parameter. We talk about approximation algorithms. We talk about streaming that you have a limited memory. We have talked about classic algorithm. This is the fixed parameter algorithm. The whole idea of fixed parameter algorithm is that all this branch and bound or backtracking algorithm that we have some kind of theory for them. So, for example, you want to find the vertex cover, a set of vertices that when you select it, all edges in the graph at this one end points there. You can do it trivially like 2 to the n. Can you do what is the best state? The best state is 1.1 to the n, essentially. So this is the whole idea that is backtracking, because you talk about greedy algorithm. That seems more like reasonable algorithm to prove theorems. Dynamic programming. Still, there are several research. Not all problems have been solved using dynamic. Also, the other thing is the backtracking. Okay, I'm doing backtracking. Can my backtracking ideas also be somehow formulated and improved? Because they say, oh, this is I will do just some regular exhaustive search or something. Maybe do a little bit. The whole this idea of fixed parameter algorithm is that do it a little bit better, essentially. This, for example, Nash equilibrium thing that I have mentioned, for the problem that I have mentioned, is finding the source. Or finding, for example, this graph isomorphism. Getting it something 2 to the SQR root of n, like a little bit better than exhaustive search, still the great achievement. You will do it, you will get the best paper award in top theory conference. So you see, so it's not even those backtracking that the people take it granted, oh, maybe this is just something that I'm doing, maybe it's just is not that exciting comparing to greedy or dynamic programming. No, there is a theory for them. And you should just know about them, know what are the important problems in the field, and spend time on that. And again, this helps both ways, essentially the same thing that you mentioned. When you think about it, this is the same thing, that the same thing, you may solve some problem for coding, and then you want to do a bit harder problem. Just think about it. Maybe you don't solve it, no worries. You already have the advancement in your brain, essentially. Your neural net in your brain actually became better. If you solve it, again, huge achievement you have obtained it. Maybe some beyond this, several of this beyond this, like this, you became essentially, I don't know, gold medal in IOI. I will say that some of this problem, if you solve 30, 40 years, the whole field of computer science, they couldn't solve it. I solved it. Essentially, I think it's more achievement. And I have, I mean, some of these and other things, but I think like lots of people can have it, and that would be great to essentially get and achieve these things. That was the whole things that I'm trying to do. That I try to provide these videos, etc., as well as, I mean, encouraging the people. And as I mentioned, I was talking with Prof. Potter, mainly because of this. Okay, let's do this. This beautiful mind solve some unsolved problems. And again, at the end of the day, you may need to do it because this computer ChatGPT type of thing becomes stronger and stronger. If it is just some different dynamic programming, a little bit different from the previous one, they might be able to solve. But if it is a graph isomorphism, Nash equilibrium, or other things, you can get a little bit. That's the thing that probably the latest part that they can solve. And again, this is some competition, not only between us, also between us and machines. And can we get that before machines? Because they will get it. I think that given the progress that has happened the last year so far, I will say that actually this will happen.
That's
sooner or later.
Sooner or later, yeah.
That is some of the things that like the, I think, like, I think one other thing that we wanted to talk, I think we can probably add. So I think, what are the, like, when you do the mistakes, so like if you want some problem is given to you, so this is the during contest.
Yeah.
What are the mistakes that you can make it and you should try to avoid it? What are the main things that you can do it essentially?
During contests, there's a lot you can do. Like, probably bad time management is the biggest thing. Like dwelling on a problem for too long, especially in IOI, when you have like any contest, I guess, where the difficulty is unknown, like IOI or ICPC. Like if you dwell so much on one problem, like you might be missing out on something that's easier. And probably you would want to budget your time so that you give each problem a chance, I guess. That's sort of like, I guess, suboptimal time allocation. Other things, I mean, succumbing too much to stress will just destroy you. Like it destroys your ability to think and stuff like that. There's, I guess.
Let me add another thing to
yeah.
Actually, I think this is again, this is the work that somehow comes from the after part, but it is actually useful for this. This is the, again, I mentioned briefly, similarity of writing a paper and code.
Mm-hmm.
One of the things that I will mention essentially, and we should all, when we write the papers, we should try to go through this code, through this actually writing a lot to improve the writing. It's the thing that essentially you might want to present. This was actually my master, Naomi Nishimura. She was my master thesis advisor. She mentioned that you may write a paper one time, but maybe read, I don't know, thousands of times by the people. So it's better that you spend more time to present the things better, such that they can actually read it better. Now, having this mind, then what about in coding? I think one of the things that I will do it all the time for my codes is that, and I will mention actually some of this ICPC, there are more people and there is one computer. You can always read your codes. Because this is the same thing. Why do we read? One of the things that we are doing for reading the papers, two purposes. One, improving the presentation.
Mm-hmm.
That may be, I mean, a bit less of concept. The other thing, make sure that there is no bug in the paper.
Yeah.
But, you know, it's exactly the same thing. And this is the issue. And of course, it would be embarrassment, especially if the important problem, any problem, if you publish in a conference and say, oh, there's a bug there, it's very bad.
Yeah.
And generally, it is on the authors. The same thing here. Actually, one thing that can add to your stress is in some of these contests, especially, for example, this one that we can, there's an online judge that you can get some kind of feedback. You submit the problem, you solve the problem. There is some special case that you didn't consider. Or there is some, the algorithm maybe need to change slightly, essentially. You didn't think about it. You have just spent your time to write it fast. I think this is the whole idea of thinking. This is one of the most important things that also helped me when I was talking, as I mentioned, I went to the bathroom, such that I have some time, such that I can think about the problem before doing the coding. Always do a lot of thinking before coding, because a code that is essentially written bad, it would be a huge mistake to try to actually fix it, because you have a good luck essentially to fix that code if it is not written correctly, or wrong algorithm, complicated algorithm, try to fix it. You will spend a lot of time on this problem. Probably at the end, you may not even get the result, the thing for that. So spend time such that you can write the beautiful solutions, essentially the most concise solution. But also read this code several times before submitting. Even I will say in the ICPC, because always there is a penalty. So try to read it a few times. Did I consider this case? Did I consider this case? Is it exactly the same thing that when you write a paper, you will do that? Because you need to say, I have written, I proved it. Is there any case that I missed? That's a typical bugs in a paper. There is some case that you didn't consider. The same thing that happens in coding, that you have some mistake that you missed it. And the worst thing is that this also has a strong relation with stress, because if you submit this wrong program, then you will get a wrong answer. Then actually the stress now adds up, because you thought that you spent this time. The others, they have done others. You spend all this time, this hard problem. You hope that you will get it, and you will solve the easy problems. No, you cannot get it. It adds, and stress adds up, kills all the essentially even the correct way of trying to solve this problem. So I think this is lots of similarities between that, and read it. Try to do more thinking. Make sure that your program is correct, because you love that when you submit it, say, okay, you got it. That's a beautiful thing when you get the things. It means that you have done the job correctly. And the worst thing is to get essentially wrong answer and you submit. Again, this may happen if you already solved the top things, then you don't have any time to do it. You cannot solve any other problems, and all easy problems are solved. That you may do it at that time, for example, at ICPC. But for example, in IOI, probably this does not happen, that you are doing at this stage, because the number of problems are not 12 or something. They are like easier problems. These are 3 problems that you need to solve in 5 hours. Maybe some of them have some subtasks or something. So thinking, reading, and thinking before submitting, I think that has the huge things. For example, as I mentioned, if I thought, I think I was trying my best. This happens. Anyhow, the mistake can happen in the code, even if you read it. I just forgot to appropriately, essentially reset my variables, and I essentially lost code versus thing. And this is one of the other things that is also another interesting thing. I have seen actually several people, I can name a few, but I don't probably want to name. These people all got a gold in IMO, which is also very hard. But they got silver medal or bronze medal even in IOI. Exactly because of these mistakes. Because I said, oh, this is a mistake. Yeah, but this is part of the thing. You got it. You deserve to get it silver. Yes, I deserve to get it silver because I made this mistake. I should have not made this mistake. And this is lots of people essentially, especially in IOI, etc., especially for those things that you cannot get the feedback, they have this. I think now probably it is less of a problem. But if you cannot get a feedback, you cannot do the online judge, then you may submit it this one, and then you just missed essentially some small things, and there was no chance to fix it. And so lots of these things, probably less, a problem now because you can get a feedback. And that's something that any other things about the mistakes that they can, the people can think to.
I think the I guess the proving aspect is important to think about. Like, I guess not strictly proving, like verifying your own code. I think like everything else, it has to be a balance, I guess. Like it depends on how much you specifically spend. Like I personally usually like skim my code to make sure that everything I'm doing is sane, even if it passes samples, just to like look at everything and make sure like, yes, this is what I wanted to do. And then that's enough for me to submit. I'm not sure. It's hard to like read it over, for example, multiple times, because I mean, edge cases are a good thing to look for, I guess. But if you're like at the beginning of a contest, for example, that those few minutes are going to count for every problem afterwards. So it might actually be better to have a risk of a penalty rather than lose 5 minutes and then lose 5 times 10 penalty if you solve like 10 problems after. I think
that's actually a good point that you mentioned. I think that one thing that can help on this case, I mean, this is like, again, so something like, for example, ICPC might be a bit different from IOI in that sense, because you may have, I mean, 3 problems you already, I mean, essentially solved. You just want to, you don't know the test cases, maybe the end essentially comes later. But I think it's the one point that you mentioned. One thing that I mentioned, the thinking is good, and you should do that. But this way of writing a program without error, that's actually, that is some kind of, I will say, maturity. Not everyone can make it. I mean, it takes time, takes effort. And I think this is one of the things that is useful, that the people spend time on it, that try to write program without even one error when they write it. Of course, as you mentioned, there is always cost of reading the whole program. There is a cost for that. The same thing again, we have it when we prove a theorem. So there are some people that they may prove this one. They're very smart, but they make essentially lots of mistakes, and then they try to resolve this mistake. But there are some people that when they say that I solved this problem, then no, this guy said that I solved it, it means that he solved it essentially. And probably there is no bug to fix it essentially. And I think lots of them actually comes out of more so essentially, the way that you are doing this time when you write the program. At that time, you are more focused, such that you can write the program such that there is no essentially things. So in some sense, if you can increase your focus when you write a program, at that time, potentially you can actually decrease the
be careful
probability of the code things, and they can save the time. Of course, as I mentioned, this means that at that time you need to have more focus comparing to a regular person to do it the things correctly. And so this is also another interesting thing. Also, this one, as I mentioned, the people are asking me, what are you doing? Oh, I'm solving the same problem that I was solving, I don't know, 30, 25 years ago when I was at IOI. There is one other difference, and it is actually interesting, that also when you do, I think this was one of the things about what is the research life versus this one, that some of the problems that I mentioned, these are hard problems, nobody has solved it. Interestingly, several of these problems that I solved, that happened when I went asleep with these problems. I woke up and said, okay, I have some idea. Maybe that was not the complete idea, but I could work on it and I could make it actually work. In some sense, we are using this kind of ChatGPT idea that we are just this problem. I asleep, maybe I don't care about, I mean, like I see that I'm unconscious in some sense, but the brain is still, the neural nets are still, they are working. They come with some kinds of maybe ideas that in the morning you will go there. I will mention some of the things. Is this harder problems? This is one of the main difference between the more a bit researchy life, that some of these problems, yes, you don't need to do, I mean, some of them you may need to keep it in your mind just for a longer time. And you know, one night, this may happen a bit less in this kind of during the competition contest. A bit happens more in the research things. These are harder things that you say that, like, oh, no, this is the solution. Lots of this is when you think about this solution, this is the one that I mentioned. Probably much, much easier than the previous solution, and much, much better. And this is exactly the moments that happens essentially for lots of us when we are doing that. So that's a little bit, I mean, thing different, that you don't solve everything. And that's the thing that you need to have also a little bit more patience. Don't say, okay, I don't solve it. Yeah, you know that nobody in the world solves it. And of course, and this is the interesting thing. So you solve, for example, one of these problems. one or two of these problems, you get essentially the best paper award. You may get, I mean, as a PhD, I mean, if you don't have a PhD, you get a top school. If you have a PhD, you may get a top school as a professor, essentially. This is the level that is so essentially rewarding comparing the things. This one also I have seen, for example, more people from, I don't know, maybe East Europe or China. I mean, it's good. Again, I worked at Amazon, Google, all of this. These are good companies. But these companies, what do? They try to get these smart, this is another, I think, interesting thing. They try to hire these super smart people. Why? To just improve essentially ROI of their company. They just increase the profit of their company.
Yeah.
And one of the things that you will lose here, it is good. This is advanced. And some of them actually, like Google is good. You can publish papers. At Amazon, it is hard, or Apple, it's very hard to publish papers. But the interesting thing is that, I mean, here, in this, generally, I mean, if you go to some of this, like this, even before you start your essentially undergrad or other, because you have all the knowledge, as I mentioned, all the knowledge I had it from that camp that I had done it during my high school. I learned everything almost there. And again, nowadays we see YouTube that I will put or others essentially, you can get everything that you want essentially. Then you will do and solve this one. Then you have the time that you have more. This is exactly the idea. When you go at Google or I don't know, some company X essentially, you solve the problem, you increase the things. But at the end of the day, no one noticed that you have done these elegant things.
Yeah.
Yes, it was actually interesting. So this was one of my PhD students. He went actually joined Microsoft later. And then he was publishing papers and he was solving actually important problem. He had again some IOI background. And then he came said, okay, I want to publish. He talked with his boss. I said, okay, I have this nice result. Can I publish it? And I said, okay, I'm not so sure about publishing, but I can essentially bring you such that you can present this one for or VP essentially, like the vice president. That it was a joke. I mean, why should I care a VP cares about? I mean, this is not enough for me that a VP cares about you. I already got so much rewarding things that a VP say it is good, maybe adding a little bit more money. That is not enough for me. Yes, if it is your own company, you are doing that, that is great. But just adding a VP, I think you are just selling your precious thinking just to essentially cheap essentially. Because you can solve this one, you can solve some of the problem that nobody has solved. As I mentioned, several of these people, they don't have even formal background that you have it essentially here. And these companies are using these things that say, oh, you don't know that, especially if this happened more, I would say, somehow outside of the US, like in East Europe or some of the Asian countries, that these people all thinking, I have been in some of these companies and they say, okay, this all they think is that I can get, for example, this company X, Google, Microsoft, find the stuff essentially get it. This is just too low. If you are good at it, you can get much higher, you can get much personal recognition. And that is super important for you to make it. And you can make it, as I mentioned. The person who has experienced this one, at least I have been there in this business essentially, I don't know, from 1990 to now essentially, like, I don't know, 30, 40, 35 years essentially, I can guarantee that if you are good at it, you can solve some problem that nobody has solved, and you can get much, much higher recognition. And that would be good for the field. And anyhow, this is some of the things that it will remain, hopefully some of these robots will refer you. That's something that I think is good to think a bit like this, and don't sell yourself. I will say, I mention this thing sometimes, the people say that, boy, you are at the end. I have been lots of companies that came back. Okay, what is this thing? Okay, I didn't want to sell my soul cheaply, essentially. I mean, this is just some thing. But anyhow, if you have the capabilities, I strongly recommend you to do it. Writing, sometimes it was a barrier if you are not a native English speaker, but using ChatGPT, actually, you should always improve your English. I think that is very important. I think that one other thing probably in the people outside of US, that if you go to IOI, as I mentioned, IOI still, I believe that they are doing the translations. But I think that, and especially IOI is much harder because there are long problems that they need to solve. So you really need to read it, and this is really a real world problem. Some of these words is hard to find it in dictionaries. So this is translation versus in math, you have 2 lines and everything is clear what you want to prove essentially, like in IMO. So I think improving English would be good. Working with ChatGPT would be essentially very useful. And then if these 2 are good, then you can write papers as well and solve the problems essentially for this. So I think this is like, we talk about lots of things. Is there anything? I think this was one other thing that I want to ask this one. So do you recommend a different practice strategy for different skill levels? So
right. Yeah, I do. I've thought about the answer actually. I think the only exception to just solving hard problems, but like probably the general strategy I would describe is pick some random problems that are expected to be hard for you, and then just spend a long time on them. And then you don't have to like go out of your way to learn things, I guess. Like if you can't solve a problem and it's because you don't know something, then fine, you can go learn that thing. And then like eventually just by doing that, just by solving these hard problems, you'll like encounter all the things you need to know to solve the problems that you're intending to solve. And so I think just doing that is enough pretty much everywhere. And like the only exception I would grant is if you do have like a mathematical background, like if you already have a strong problem solving background, then when you're starting out, really what you need to do is just accumulate knowledge. You need to just understand the like all the algorithms, the fundamental stuff you need to know and stuff like that. And then once you get up to speed with that, then you can again go to like a general practice strategy. So I personally wouldn't. I think a lot of other people have differing opinions on that, but I think that strategy holds up pretty much everywhere.
Yeah, I think actually I want to borrow just one thing from the thing that you mentioned and add to that. I think this writing program with lots of focus. I think that's also super important. So like you are completely focused when you write code. That is super important because that I think that's something that needs exercise. As I mentioned, for example, when I was writing this Delany triangulation, or I was writing this matching in general graphs or something like this. One of the things that was very important that you need to have lots of focus, because if you don't do that, essentially, there are all variables, etc. The code can become messy and you may not get it essentially right. So focusing to write a code that, as you mentioned, that would be beautiful that when you write the code, you will compile it, it works and pass all the things. That needs some exercise. That is just math. Maturity is not enough for this. You need to do some exercise essentially for this to do that. And so one other question is this, what about the ChatGPT stuff or Copilot? Should you use it when you prepare for this contest nowadays that they exist, or you should avoid
them? That's a good question. I think for practice, like it's only going to hurt you really. Cause like, I mean, the goal for practice is for you to get better. And if you're like sort of taking these shortcuts, using these things that are sort of doing the work for you, then it's kind of ruining the whole point. So I think for practice, it's not a good idea, but if you're doing an online contest and it's allowed and like, it might give you an advantage, then sure, go for it. But I think for the sake of trying to improve, I don't really see how it would help you that much, I guess.
And as far as I know, on something like IOI or USACO or like, for example, ICPC, they have very strict things. They don't allow any of these things. So you have a very limited knowledge. Everything that you have is very limited number of pages that for example, you can have it in ICPC like 20 pages. And the people try to put as much as important things there. But that's it essentially. I'm not sure even for IOI or USACO, you can have some kind of cheat sheets even with you. Are you allowed on these 6 competitions to have some cheat sheets for you or not?
For USACO?
Yeah.
No. No internet, no anything.
Nothing essential. So that's the thing that you should try to avoid them essentially. I mean, it is good if you want to write the software that is very good and you have time. And also probably also takes time because this is the issue that probably this problem, this is one of the things that have tests. And these problems are not smart enough to do that. Maybe for input output, they are good. Some simple things, some regular expression you want to get it is good if there's something there. But if the problem is a little bit different, probably it takes more time essentially. And maybe unless there is some particular procedure or something, but if it is the case, you should have written it enough that you can essentially just write the code yourself. And that's the idea. That's what part of the practice that you should do it there. So let me also ask one, I mean, general question, maybe now we are coming to the end of it. We talked essentially almost 2.5 hours. So I think you have this, I mean, like essentially great, as I mentioned, this is I really appreciate this channel that you have. I'm not so sure that other people who have spent on this one have such, there are lots of these people about programming, but the person who has participated there, he had a very high standing there, having such kind of channel. I don't know any of them. Do you know any?
Like, wait, like what specifically about it?
I mean, something like, I mean, a person who has like participated in IOI or USACO or like ICPC has a very high standing. And then there are
a couple other big names, like William Lin, for example. He's sort of like, I guess, the figurehead of competitive programming on YouTube. He did this one video where he won like this Google competition and it has like 8 million views.
I see.
Probably everyone in this chat knows him, but like, yeah, he's and there's another one, Ericto, who sort of did the same thing, but he focused more educational. So there are actually, and they're both like really, really good. Like William Lin won an IOI actually. So they're not that many, but there are a few people who do YouTube and are really, really good. But yeah,
that is great. I think these are like, these are the great things to have. This type of essentially things. There are not too many of them, but I think it is great that you created this one. As I mentioned, for me, I try to get it essentially more after part. I try to get the thing that I'm teaching. These are the several years. This is the same way, as I mentioned, the same set of problems, maybe a bit harder problem, but the same tools essentially, maybe a little bit more tools. I try to present these courses this way, try to prepare it, present it in the YouTube, such that the more educational, especially for the after part, the more researchy part. So how do you essentially, what is the elevator pitch or the thing that you are thinking for your YouTube channel so far? Of course, it is in the programming coding. Is there anything that they try to distinguish us from others? Have you thought about it?
I mean, recently it's kind of not actually been about programming. It's been about, I'm leveraging psychology and sort of neuroscience to hyper optimized problem solving skills. That's I guess what I'm doing. And it of course applies to competitive programming because like, I mean, it's designed for problem solving in general, but I think in general, like that's my appeal, like taking a psychological approach, which is something that I've never seen done at all in the context of problem solving. So it's unique in that sense. And well, yeah, or at least specifically in competitive programming, it's never been done. I'm sure other people have taken that sort of approach, but I think, I have good stuff to share, I suppose.
I think, that is great. I think one thing that I really suggest, I think this working on the stress stuff essentially, that, I mean, I think like this is also some kind of psychology, as I mentioned. So if you can, I mean, there are some people who are, because this is like a health of what I mentioned. My health, I think, has been affected by this kind of thing. I don't regret. I prefer that maybe I live shorter, but I have a more impact essentially.
Yeah.
I try to do more exercise. I think one thing that I will mention also, I think this is the one that I always mention to my students. I think maybe it's one of the 2-3 great investment that I have done it in my life. I bought essentially a treadmill, $180. It was sale or something. And that is one of the best investment that I have done, because any time of the day or night, sometime midnight, I will go and then I didn't do my exercise, I should do that. And that really helps. I was playing like ping pong and essentially or table tennis essentially, that or swimming, that really helps. So this is one of the things. If you want to solve the problem, go and spend some time on the sports essentially, even not the professional, but that really helps essentially, I think, for the thinking and makes you essentially healthier. Yes, this takes a lot of time from you, and you need to spend it, but try to, anytime that you can do it, some exercise, and that would be something, great that we can do it. And another question, I know that actually you are spending a lot of time for this, for example, ICPC and others. Are you using these techniques for your writing program as well, or at some level essentially?
Yes, the things I like in my videos and stuff.
Yeah.
Like, yeah, the things I do in my video are things that I do, like not as intentionally as I offer them, but sort of like unconsciously, subconsciously. Like one of my biggest videos is on intuition. And that's like, something it's a strategy that I use at the very beginning to sort of catch my brain up to the knowledge, I guess. And I've sort of been like, I don't do everything I say in my videos, because some of it's like applicable only in certain scenarios, but I do a lot of things. Yeah, I do. I follow my own advice somewhat rigorously, I guess. I think it's sound advice. I like it. I like the things I offer in my videos. I'm proud of them. But yeah, I guess in that sense.
I think that's actually good, because I think this is important, because, like, for example, I'm working like an algorithm. This is like this is the course, of course, you know about it. This algorithmic game theory. So this is the idea. The game theory is more econ type of things. But the issue is that if a computer scientist, and of course, you need to get the knowledge from econ people and use it. But several of my students actually got PhD in this area, and this is like a huge area, because all this kind of advertisement, auction, everything, that they are using both computations and economics and essentially, and unit. I think these things also refer to your thing, because if the people hear this thing from a psychologist can talk about it. If you want to solve the problem, do this and that, but that may not be that effective as you. That I know that you are spending so much time on this problem. You mentioned this one. These are hard things. Of course, it would be good to maybe read a little bit about maybe psychology and some of the things that are there, combine it with your things. I think that's always the same thing. So, like, I was doing game theories. Okay, I need to read some more econ papers. Lots of this. For some time, actually, people in computer science, they were ignorant about econ papers because I solved it. But this problem was solved by economists 20 years ago, essentially. So this is the thing. It is important. I think some of them we need to get the knowledge, but always combining this different knowledge, especially at the higher level, that seems very good. And I think I appreciate that you are doing that as well.
Yeah. So
any other things that we want to discuss, actually? Any questions from the people?
I'll look at the chat. Let me see if there's anything interesting we could talk about. I think many of the questions are pretty personal. If you're in chat and you want me to answer something and it's like specifically pertaining to you, I think it'd be easier if you just talk to me on Discord. I will link that again, but let me see if there's anything like general that we could do. Oh, there was one. Do we think that like big contests like IOI and ICPC will eventually maybe shift towards, like the heuristic problems and stuff like that, like the optimization ones where you do we think there'll be a shift to something like that in the future?
I think that's exactly the question that I asked essentially Prof. Bill Potter. This is the thing, because I think that was somehow my thing is that this is the issue. When you are limiting to this more polynomial type of algorithm, then the set of problem that you have is so limited. You are just doing dynamic programming, just mention it differently.
Yeah,
and that might be you don't get the best. This is not the best evaluation. I really believe that actually and mentioned a very smart answer. So, okay, actually, the people like you that you know that it is good, I think that you will come and essentially try to do the test. Unfortunately, it is the case. I mean, the people who are designing the judges, not everyone essentially are coming. And I'm very happy, like for example, Zach, or there was another person, I forgot her name actually. These are the people from the TCS community that they are coming and adding more that would be good essentially ICPC for ICPC. But I believe essentially still there is some disconnect between the TCS community, which is a very natural next step after IOI or ICPC, and this competition. And I know, for example, Brian, who is with USACO, because he was actually, we were both a student at MIT at that time. But I think it is important that more people from each of them, more interaction. If more interaction is coming, the people from TCS also try to make this harder problem other. Because putting them, for example, a streaming algorithm, a fixed parameter algorithm, I don't know, this game theory type of things, putting it, I mean, some of them are optimization in some sense, but it's a more general set of things. We have some, they are different, the techniques are different. Putting them there, it takes energy. It is not a trivial thing. You need to think about it. For example, I'm talking about the matching. Can you get this matching better than two approximation? Two approximation, that is fine. We can do it somehow. Maybe approximation is still used in it. But what about less space? How can we put essentially less space there, for example, and think about it? These are some of the things that needs more thinking. And maybe the people, the judges, I mean, maybe they are aware or less aware of this, the people who are designing problems. And maybe it's more work. Maybe it is less rewarding for them because they need to do a lot of time. And maybe at the end, because the other judges, this is like somehow the democracy. This is the bad things about the democracy. If I have this new set, this new problem that I want to suggest, and all other people just consider the classic sense, they vote against me, against my problem. So I don't have that much incentive to bring a new area. So I think more diversity would be very helpful here. I try to advocate that these people that are working in these areas, coding, competitive programming, should do more TCS open problems there. I think also the same is correct. The people who are working on TCS, they should find, essentially they appreciate and they should find more opportunities to come and try to change this competition. I hope that it's become more general because, again, you don't want the case that, in the ICPC, these are a particular set of techniques that you should just try, just repeatedly, and then you become the best in those and you can get a high ranking. That is not the good thing. You want to get it more weight essentially to the thinking part. And the same thing that the code force that I mentioned, getting the higher levels. And I think that should go there. But I agree that essentially, I think this is the one that mentioned by Bill as well, that getting more, this kind of writing these programs and more testing them is non-trivial and should be spent time on it. Mm-hmm. What do you think? It was like, you also expect that it goes or not, essentially, more to
I guess it depends on demand, honestly. I mean, I personally think probably the big contests themselves, like ICPC, like the World Finals contest, probably won't do that. Because I mean, as is, there are a lot of people who like the current format. There are a lot of people who like the competitive programming stuff. But I think there could definitely be a rise in side contests, like the ICPC challenges they offer and stuff like that. And I mean, AtCoder's doing their own thing like that. I mean, TopCoder has for a while. A lot of sites are. It's not as much, but it's definitely coming up, but sort of independently, I would say.
Yeah, I think actually some of the things that, for example, Google has done it. Google has this Google Code Jam or other things. They have the optimization version. They have the parallel version. Yeah. And I know actually some of my students and postdocs, they were in the top 5 or top 4 essentially these things. These are optimization parts, or for example, the parallel programming. So this kind of things you are writing with Spark essentially, how you can do it. And these are again new ideas. I think they should come, as you mentioned, this is somehow the good things or the bad things about democracy is that changing it would be not that easy, essentially.
Yeah.
So if the people still like it, the people have some, I will say, have some kind of stock in this type of, in this current way. They don't want to lose it, essentially. It takes time. But I think, I hope that it becomes more general, or at least there are some side things because that are, again, at some point, if you have these programs, you will give it to ChatGPT or Copilot. They can solve it. At that point, this becomes obsolete, these competitions. You need to add it. You want it or not. And this happens, we want it or not. I think this happens in the, as I mentioned, they mentioned it happens at Google, they mentioned 2016, it happens 2023. So it may come much faster and then we need to change it.
Mm-hmm.
Any other questions?
Let me see. Thought processes change under high pressure. Think about that. I'll answer that personally. As far as what we can talk about here, let me see if I had anything personally. The coach. Yeah. I guess, okay, given that you have a lot of like, that you've been in this for a while, and I mean, that we've been talking about sort of the style having changed. What was the style like a long time ago? Like, how has it changed between, I mean, say 20 years ago and now? Like, I mean, now there's a lot of focus on thinking itself. Was it always like that, or was it sort of?
And as I mentioned, actually, it was not like a thing. This is, I think there was a book that was say that somebody has written. Something essentially goes back, comes around, essentially, or something like that. So this is always this tension, essentially, that we have it. So this was, as I mentioned, at that time, because there was less computer resources, actually thinking was important. Then for a while, essentially, thinking becomes less because I think you could have the program. But now say, okay, we have everything, even the ChatGPT can solve the problem. Now we need to do more thinking. So that's it. Actually, my time, it was the thinking was an important aspect of it. But one thing, another style thing, I think it is different at that time, is that we were writing more with this kind of editor. For example, I was writing C or C++. Interestingly, for IOI, and I said, I changed it to Pascal. Why? I don't know how many of you know about Pascal, or this is another language, essentially. I changed it because at that time, there was a compiler that was actually, you could use C++ or Python or Pascal. But the Pascal, there was an editor that actually you could give some runtime error or Stack Overflow or something like this. In C++, these are harder to check. So for us, essentially, we were trying to use those type of Stack Overflow, runtime, etc. That was helpful in if there is some bug in the program or something like this, try to solve it essentially. That was the reason that I was doing Pascal. I think nowadays, lots of people are doing C++, and some people are in Python. You cannot use it for the super efficient one, so C++. But at the same time, I can tell you, C++ has changed also a lot. Like this C++ that I was doing at that time, so this kind of, I think, TLS stuff, essentially, all this vector stuff, all this, I mean, I don't know, like heaps, all of these are there essentially. They were not like that essentially before. Nowadays, if you want to write it, you need to know about good knowledge about this and try to use them because they have written quite efficiently. So in that sense, actually, the level that we are writing is much higher level than the level that we were writing at that time, essentially. Because, for example, this TLS stuff, you need to use it, essentially. If you don't use it, you will use it, essentially. Right. It is a default that you can use it. So there is so in some sense, it became higher level at that time. But of course, with C++, is not the level of Python that anything that you want to do it. you can't just get a package and just do the job for you. You are just essentially, you are not writing programs. Sometimes I will say to my student, my son, that you should write the program. You should not just, actually he knows C++. And C++ is a good thing because then you need to do lots of things yourself. You cannot just, still it has advanced quite a bit with TLS. But yes, at Python, if you just get any package and you are running, you don't write the program. You just essentially running some application, essentially, bringing up some application. I think in that sense, it became more higher level comparing to that one. And also maybe there is a more shift that the people, as you mentioned, this way, I think maybe at that time it was there, but this way that you will write the program such that when you write it, it is correct and you don't need to go and to debug it, etc. I think there are more emphasizing that currently comparing to those times. Because as I mentioned, C++ is like that if you write it, the debug was hard. That's the reason that we're using Pascal. But somehow it means that the debug was an important factor at that time.
Mm-hmm. Yeah, that makes sense. Okay. Regarding other things. Wait, hang on. Yeah. The question for you. What do you think about, I guess, the split between like the real life problems and the stuff in competitive programming? Like how similar or different would you say they are to?
Great. So I can't tell you. So this is another thing that I want to mention. This is actually a good thing. So I remember that several years ago, this was after, like when I was at MIT. So we were talking this one person, and a friend that I had at that time, he's at Google. He was talking with another person. Okay. And it was this person, I think it was in good university. I don't know whether he was at MIT or not, but he was saying, okay, if you want to do that first, you should do this, and then you do this, and then this, and this. He was trying to give the advice that these are the steps of the thing that you can essentially do, and essentially optimize.
Mm-hmm.
And that person said that, I hate people that try to optimize every aspect of their life.
Mm-hmm. Yeah.
Unfortunately, I think after some time working in this area, I became such a person. Mm-hmm. So I'm not so sure that I like it, but this is part of my brain. I like anything that I'm thinking. So this programming and others is nothing different from me. Everything is saying, I mentioned, I think in the game theory class, if you work in the game theory, you cannot see the world without this game theory view. And everyone essentially are some agents that they are doing selfishly. The same thing here, if you do optimization, every aspect of the life is there. So, for example, I was doing some wiring in the house myself. There you try to do essentially some kind of span tree or something like this. Try to minimize the amount of wire such that you can buy less from Home Depot and pay less essentially. Maybe the amount is not that much different, but this is wired in your brain essentially. And you cannot do that. And I think at some point, if you work on algorithm, if you work on optimization, if you work on game theory, if you work enough, that becomes part of your entity. So these are like wired like that. And it would be very hard to essentially go around. Like it or not, again, it may bother you because why bother you? This is the thing that I mentioned. Sometimes if you don't understand something, it's much better for your health. Why? Because something happens, okay, everything is good intention. But if you know what was the bad intention behind the scene, then it is a different word to you. And then, you cannot be the same person. Oh, these are the people are essentially doing crimes. How to other people? No, these are all doing their job essentially. No, they are just doing back of the things essentially. These are like, I don't know. You can give lots of these examples. And then it has some effect on you. So again, good or bad, because if the person, if I maybe don't understand some of these things, this is like the thing that I mentioned. If sometime in your life you don't have a choice, I would be much more happy because the greedy algorithm said that try to do the best choice, but if there's only one choice, there is nothing. Just take it and enjoy the life. Mm-hmm. So that is always the case essentially. And it can hurt you. It can optimize some of the things in your life. But yeah, this is part of this kind of, again, this part of psychology thing that in the long run, I think it would be good. There are some people essentially understanding it, good or bad, essentially.
Mm-hmm.
Have you thought, what about you so far? Do you think that programming has changed your life as well?
I don't know how much of my current state can be attributed to programming. I have definitely become a lot more analytical. Like I spend nights just walking around campus and figuring myself out. Like I don't know if I can blame that on programming or if that's just my nature, but like something has caused that. And I mean, I would say it helps, I guess. Like it helps to understand myself, and I'm not trying to like necessarily optimize my life. I'm just sort of trying to understand, I guess, just myself. But
there are actually some studies on that one. For example, I mean, this is the thing that they did mention, that if the parents of a child are both engineers, or I will say this one. So this thing that I mentioned, it comes to my life and it is somehow wired in my brain. I think even changes probably some genes as well, because there are some studies that shows that if both your parents are engineer, the chance that you will be, I mean, essentially on the spectrum. Spectrum is essentially the thing that they put it for autism or other things. The chance is actually higher. And autism, what is the main meaning of autism? Essentially, it means a different way of thinking. That is the main, essentially, intuition. Sometimes it becomes much better in some aspects, and some other things, like, for example, your social life may get affected, but you may solve the problem much better.
Yeah.
And that's the thing. Oh, this is also one other thing that I've been actually mentioned to my students and others, that try to, I mean, I think it is important. It's like you want to be very good at essentially about the IQ stuff, but the EQ essentially means the social life things. I think you should work on it. Lots of people who are working on the programming, I tried myself to do that essentially, and I think I improved myself a lot of that. I think the people should try to do that. This is important, because if you don't do that, in the long run can hurt you actually. And again, these are not some hypothetical things. If you do it enough and deeply, I believe that it can change it essentially. Not only for you, but the whole generation it may change. So it is good, and it is very interesting. This kind of the game theory that I'm working essentially is part of this kind of social sciences, etc. That you will go do something. You need to be social at the beginning to just do that. You should not just think about socialism or this if you don't be social. So this, I strongly recommend that the people try. And I think it is important, because this is one aspect of the life. You don't want to have total, essentially, trade-off toward those type of things, because that, as you mentioned, I mean, that can be dangerous. I mean, there have been some problems that bothered me. This is a bit unfortunate, but unfortunately, some of the important problems, I couldn't solve them until it bothered me. I don't know, maybe in the period of a few weeks overnight. I couldn't sleep because this problem is in my mind and I cannot solve it. And because of that, I could solve it.
Yeah.
But it bothered me during this time. So there is some cost. There is no free lunch.
Yeah, I've sort of hit that dilemma with improving myself, like that I have to care for it to really work, but like the fact, like the process of caring is like really annoying. Exactly. So it's sort of like it's kind of hard to tell exactly what you should do. Have to judge, I guess, what's important. Yeah. It's tricky. It's all tricky.
Yeah, it's tricky. And there is no free lunch, essentially. If you go one way, you may lose something.
Yeah.
You cannot be I think there was an interesting thing there. You cannot be essentially like in a sport, be very good and be good as scientists. So there are some, but very few. I think there was one, I was reading, some famous basketballist or something got hired as a professor at MIT. So that was interesting. So that happened, but no, you cannot continue for there is something that changes this equilibrium.
Yeah. Okay. Don't really see anything else. Yes.
I mean, we already had actually 3 hours. I think that is good for this time. I think hopefully the people, I mean, use this. As I mentioned, I mean, I think you have lots of interesting things that I haven't looked at, essentially, your thing. I have also prepared, I mean, this one I have, so at my YouTube channel, I have prepared a few of these. I mean, I have set up the courses that I try to have my courses, the best presentation, such that the people with the background can come and read it. And I will mention open problem, etc. there. I have also a set of live videos that I bring with famous computer scientists in different areas. And they are also mentioning about their life, lots of things about their life, their things. Even some of them, they are talking about their chair of the department or like essentially dean of the college. They are talking about their experience there. And at the same time, they are talking about open problems in the field that they are working, different fields, robotics, AI, vision, crypto, etc. All things that we had it. I think that would be good. And also I have this kind of potential of e-commerce. This is my experience that I put it essentially say, if you, because I have been in this company, essentially different companies, and say like a person who knows optimization, try to understand this one and present it for the people who may not, and these are some of them, for example, advertisement. It's a very complicated thing. I spend a lot of time to understand it, what is the thing going on. Or like, for example, some of these, like, for example, Kubernetes or this concept of microserver. Again, these are beautiful concepts. And some of them, for example, I use dynamic algorithms essentially to solve this one. These are a typical type of algorithm with insertion and deletion, and you can use it, for example, for backend of online advertisement. I think these are interesting, and I have presented even this course, Principles of Data Science, that I will put the videos later, to just essentially transfer they generally say transfer your technology from academia to industry. I think I have done it reverse, from industry to academia, because lots of things that happened to me that, for example, I wanted to do something, I want to create a website. I have tried to with HTML, then JS, then I tried to do it essentially Bootstrap. And then at the end of the day, it came React. I say React is I reached to the conclusion that React is the best. But good luck if you go and search on the website which one is the best. Then I also had some contacts, some other people say, oh, React is the actual one that the people are doing it. Some of this is very hard to read it on the web, and it takes a lot of time to actually find out. Or like, how is it going with this kind of RESTful AI, APIs essentially, this kind of communication, boss-based communications versus one-way communication. And then at the end, you say, oh, these are beautiful things actually. I should have thought about it. But there is nothing on the web because you have some kind of more programming theory background and algorithm background. And these are a bit different, system background. To get it, it takes time essentially. And like, for example, another thing I think I recommend people to, I was actually reading some of this, like sub-pop things at Google. You may, if you search on it, it is a beautiful language actually. You can do lots of things. I'm not so sure there are too many papers there essentially there even to talk about sub-pop language. So essentially something it is used in Kafka, for example, for scheduling the task. But I have written this, these are the beautiful things you can do it. And if you know about this kind of the world of microsystems or microservices essentially, etc. I mentioned some of them there essentially, and some of other things I will mention some of the courses. I wish that I still actually try to have more opportunity to do that. But I think these are some of the things that this is one thing that I will say that if you have a theorem on, if you have algorithm on, if you have worked in this area for a long time, if you go to this system area, you can see the system in a completely different way, and you can make something great things happen. Another good person that I can mention, Jeff Deans. He's a senior VP at Google. Almost all Google research is reporting to him essentially. As far as I know, he's a great person essentially. He has done lots of great things like MapReduce, this kind of the big table stuff, Word2Vec stuff. Some of them, of course, later the other people help, but some of the early work that he has done it. And if you see his work, you will see the beauty of theory actually is in the practice that has been used. And because of that, actually, he built these are very famous systems that he has done it. And I think I really appreciate that because that's also something that we use somehow kind of more theoretical thing in practice. But I think lots of these people, also I will say that this is one super important thing. These companies, lots of you, they try to hire software engineers. Don't sell your soul cheap. That is super important. If you go there, try to get the whole idea of the company. Some of them I try to say in my, like this this potential of e-commerce, but you will find more if you do it yourself. Try to don't be just very shallow to see your part of the code or this change of the thing that you are doing. Try to understand the whole system. When you understand with the beautiful, you had, beautiful mind because you work in this type of area. And with such a thing in the smart mind, when you see that things, there are something that beauty that you can see in the system board. And not only that, you can add a lot to that. And I think try to do that. I'm sure that there are several of the people that they have been in the IOI or ICPC that now they have essentially these are great people essentially. These are the CEO of these companies, like for example, Telegram or lots of several others. You can mention that. But I think again, more opportunities for this. This is unfortunate things again. For this, I have seen it. The people with the IOI or ICPC, you become more focused in this area. As I mentioned, it has the effect on you that you become, maybe some of us essentially become less social. To go, some of this, for example, if you want to have a great company, a startup, spend some time on that one as well, then you need a great, essentially some kind of social and networking capability. You may lose on that, and then you don't want to be a tool for others to be used. Yes, of course, you should. If you get a job in some company, you should do your things, but try to all the time advance your capabilities. Add to your networking capabilities. Add to your seeing the great vision. And this helps you because then you as a person become a strong person. And if you started this sport because you wanted to in IOI get a gold medal, why? Because you wanted to be there. You don't want to say the country was good, the city was good, your school was good. You want to say that I was good. Yeah. If you want to do that, continue that way of thinking. Even in the system things, try to add the things such that you can build more on that. Or if you are doing that, you can be in academia and solve this problem. That's essentially the whole message that I try to convey. Mm-hmm. And yeah, I think that was great. I think that's a great opportunity. Maybe we can have some of this maybe later as well about talking about some other subject. But I think, that's a great, as I mentioned, my whole thing is that try to somehow convince people to think more about themselves. You already came here. You wanted to be the leader in this one. Don't sell yourself cheap. Try to continue this way. It's not easy. It has effect in your life, in your health, and way of thinking. You can resolve some of them by adding, for example, to your social skills, etc. It has an effect, but I think that is, I loved it so far, essentially. As I mentioned, who cares at the end of the day if you have some more, to me at least, I prefer to have maybe shorter life, but more impact than longer time, impact, essentially. Mm-hmm. Maybe some people tell you at the end of the day, what's the difference? Yeah, that is a valid question. I don't know. But that is essentially, if I started this, I think that's the way that I'm thinking about it. Essentially, I will say that if you have some capability and you waste it, I feel bad about it.
Yeah.
That's the main thing that I will mention. Mm-hmm. That's the thing that I mentioned, at least don't sell yourself cheap.
Don't waste.
Great. So if there is...
yeah. Especially if you've put so much time into something and then you just sort of let it die like that. Right. Yeah.
I think now it has, there was some internet.
Has something happened?
Yeah, I think now it has happened. Okay, so anything else you want to add? Final word? I mentioned my final word,
There's one more that I was interested in. Where do I guess we see competitive programming going in the future? Like what happens from now? Not only in terms of growth, but also like with some other things that are going to come up, like AI and stuff like that.
So that is, I want to say actually, maybe I will mention this final thing. This is some philosophical thing that I'm thinking. Yeah. So I think I want to answer that. I want to say that what would be the human? Because this is like nowadays, lots of discussion about what is the role of humans. And I think I mentioned this one in my classes that you see that, the people are afraid. Now we have ChatGPT, AI, we will be controlled by robots. I said that, don't worry, you're already controlled by robots. A lot.
Yeah.
Just a simple example. You want to get a mortgage for your house. Everything is computed by algorithms. So you might actually have a good credit, but this algorithm, a stupid algorithm, they decide that you don't have enough credit. You don't have enough credit, you cannot afford essentially big loans, you cannot have the house. Not only that, for example, if you call any banks nowadays, or I don't know, the airline, say that, okay, like, can you change it? Say that before 10 years ago, they could manually do something. Now say, sorry, I cannot do anything. The system does not allow me, essentially. So the system so everything essentially is doing that. Given the ChatGPT speed, essentially, this is like essentially philosophical thing that I mentioned. I don't see that. I think this is already going at, like Elon Musk, for example, is thinking about this, putting these chips in our heads, essentially. And it is already there as well. It's not there, but it's my cell phone. I'm doing everything by my cell phone. It is not there, it is just in my hand, essentially. And I think in the long run, this is my thing, that this is the whole evolution. The thing that will continue would be the computers become very strong. At some point, we will have somehow essentially combination of humans and robots. So this is one other thing actually I did mention in this RoboCup, one of these things about the founders of RoboCup competition. And he was actually from Japan. It was very interesting. He said that one of the things that we are better than the robots are essentially we can sense much better than robots. The same thing that is some of this AR, VR. So, but at the same time, I think this competitive programming, everything, at some point become obsolete because they can solve the computers, they can solve. What do we do? We are not doing that much what we do. We are just having some knowledge. We are creating that knowledge. This already happened in ChatGPT for writing. This will happen for programming. We cannot do, and they have much more power because, again, nowadays, ChatGPT can write probably better than any particular, especially in average or in long term, any average native English speaker or native speaker. Because why? Because it has more knowledge. The same thing happens here. I think my thinking is that the thing that will happen, we will have a combination of humans and robots at some point. And then this is like, at the end of the day, this skin that you will see in my thing, it has more water. A robot, maybe you will think it has more metal. There must be difference, all the essentially materials in the earth. And we will probably may change more to robots at some point. I think that's the next level of evolution. It's a bit probably the things. And it is not very bad, essentially. You know, what are the opportunities? I'm thinking that, think about this one, that like at some point we become more robots. There are a combination of robots. These robots, they may not need oxygen anymore the way that we need it. What's a good thing? They can use essentially the sun. You know, these robots actually can go from one planet to very, very far planet, start essentially some life there. We cannot go there because we need oxygen and we need to try to or things. But they can go there. They can have some kind of solar thing, some batteries, travel essentially in the whole thing, go to other planets and create essentially new things. And interestingly, one other difference between us and like humans, currently, they cannot copy-paste their knowledge to each other. Robots can easily do that. Then this is one danger that people say, actually, oh, if the robots, all of them will be the same robot because one decides for everything. So we don't have this kind of diversity of people. However, I think even that is not a big deal. Why? Because if these robots go to the very far from each other planets, they cannot communicate that much with each other. So that actually causes some diversity between these robots. And instead of just, we are doing sometime maybe just some countries essentially, I don't know. The Middle East were the things, now the whole world. Now we are somehow around us doing that. But I think it can be the whole world essentially. Lots of planets can have this kind of combination. That's the thing. But essentially, yeah. So I think to come back to this competitive programming that you mentioned, I think, yes, I think at some point it becomes obsolete. That is, to me, that will happen. Even, as I mentioned to my students, that even writing papers becomes obsolete because we are just doing something and these robots are doing exactly the same thing that we are doing. What we do, we are just, these have some neural nets. And this is also interesting. So these neural nets are not exactly the one that it is like in our brain, but there is no need for that. We are getting the ideas of essentially flying from birds, and we fly much better than them. The same thing. They got the idea of neurons from our things. We never quite understood what's going inside, but maybe it doesn't matter. This will be much stronger machines that they can overcome us. That's my current things. Maybe I hope I'm wrong, but again, that's my vision currently. And yeah, so in that sense, yeah.
Probably if like AI does become strong enough to solve everything we can, I think that's inevitable.
Yeah, and this is also interesting. Some people say, okay, this is interesting that they go, for example, if you are plumber or if you are, for example, electrician, you will be still used because they cannot do it. But the issue that they may, like, if there are no humans, who needs water?
Yeah.
Plumber, water, they all goes away essentially. These are the robots that they need to have just some essentially good solar things to get it, and then they can travel essentially much faster than us. Yeah, but anyhow, yeah.
Yeah. Okay. I think that's all I had.
Yeah. So that was great. Essentially, I think thanks everyone that will joining for this. Hopefully, it's something useful for everyone. We may have something in the future more about this stuff, and these are kind of my thinking that I had it, so we can have it. And yeah, I think that's it. And say goodbye to everyone. And
see ya.
Talk to you. Bye. And
I don't usually do that, actually. I don't know why I did that. Yeah, it's fun.
Yeah. Okay, bye. My type of yeah. Okay. Have a good day. Bye.